Hello, hello, hello. So, oh, you're over here. How are we doing? How are we doing today? We are doing very well. What we're going to do is we're going to understand how to read the abacus. So here's my abacus, and here is a number. This number here is 9,873. So we're going to do 9873. That's what 3 looks like. Why? Because if you notice that the top beat is a value of 5, it doesn't touch the top. It doesn't touch the reckoning bar. What we're looking at is the way the abacus is being read. So when we look, we're going to do 9,873. This is 3, 1, 2, 3. The top bead is not touching, so every time the beads are touching the reckoning bar, they're not being counted. Hello, 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 everybody. Welcome, welcome, welcome. I hope you guys are all well. Hopefully you guys are doing... It's a nice night, right? I hope everybody's doing well. So what we're doing is we're learning how to read the abacus. An abacus is a counting tool. It is a math manipulative, which is very different than what we have in other places. There's like these bricks that are these cubes that we do. There's these cubes, but it's kind of like using cubes, but in abacus we actually use this is actually a representation. So we have 1, 2, 3, and then we have 5, 6, 7. What? How did that happen? Well, 5, 6, 7. Yes, I had dinner already and continued. Nom nom. I hope it was a good dinner. What was for dinner? uh, So we have 7, 5, 6, 7. Notice that there's a top beat. There's a top beat is a value of 5, and then there's a bottom beat. These are values of 1. So we have 5, 6, 7. But if you're looking, this is at the tens place. This is at the ones place. So we have 3, 1, 2, 3 in the ones place. We have 7. I made a slice of thin, sliced breaded chicken with white rice and asparagus. Oh, that sounds delicious. So we have 5, 6, 7. The top beat is a value of 5 and the bottom beat is a value of 1. So when we're looking, we can count on like a kindergarten scale. We have 5, 6, 7. And then this would be 8. Why? Because we have one extra bead. So we know that 1 plus 7 is 8. So 5 plus 3 is 8. 5, 6, 7, 8. We can count up, and then we have this final number. This final number is 9, 5, 6, 7, 8, 9. Welcome, everybody. Welcome. Let me know. Thank you. Hello, I am bored again. Thank you so much for the rose. If anybody's really interested, you can go ahead and check in on my forehead where the orange heart me is. So thank you, everybody, for joining. Thank you, everybody, for joining. We're going to continue to read the abacus. So this is 9,873. And then our next number is going to be 8,000, 5, 6, 7, 8, 500, 500. This is 0, and then this is 6. So we have 8,506. Oh. Hello, everybody. Hello. Thank you for joining. Thank you for joining. My name is Lynette, and we're learning how to read the abacus. That's what we're doing. Learning how to read the abacus. So we have our next number is 7,068. So 7,068. 7,068. That's what 8. There we go. So 7, 5, 6, 7. Hello, Nom Nom. Hello, Kimber. What's up? What's wrong, Kim? What's wrong, Nom Nom? What is the wow? You get... Oh, hey. Yeah, that's what they say, consistency, right? Thank you. Have a good... Oh, thank you so much for the... Thank you so much for the gift. Thank you so much for the gift. Hello, I am bored again. Hello, hello, Kimber. How's it going? So we have 7, 5, 6, 7. We have 0, and then we have 6. Did you see one of my posts? That's like 500,000, and I just posted like 2 days ago. Something like that. And it's so crazy. All I'm doing is I'm telling you how to read the abacus. And I got like almost 500,000, right? Hello, applesauce. Yeah, it was crazy. There was that one. It was absolutely wonderful. Yeah, thank you so much. Thank you so much. I appreciate that. It's crazy. It's crazy. I'm so happy for you. Thank you so much, Nom Nom. I'm hoping it will work out. I do hope it works out. I think I'm starting to get a little bit of an upclimb. Thank you. I am bored. Thank you for the rose. Thank you. I am bored for the gift. Thank you, guys. Thank you, guys. I appreciate that. Show. 21,394. That's what that is. So we're gonna write it out. We gotta write it out. Now I gotta get paper. So that was the question, right? It was so crazy. Yeah, right? Like somebody just asked. I'm like, okay, I'll just show it. Not a problem. And so I That's what I did. It was like that one, 394. So when we're on the abacus, we do 21,121, right? Anytime the beads are touching the reckoning bar, this is counted. So notice that none of these columns are counted. We have 3, 1, 2, 3, 9. Well, how do we get 9? 9, we have to remember this is the top beat. The top beat is a value of 5. Because the top beat is a value of 5, we have 5, 6, 7, 8, 9. Notice what we're doing is we're counting on. Counting on means that we don't need to count from 1. We can count from 5. And then we do 4. 1, 2, 3, 4. That's it. That's what it is. Now, why am I over here? The reason why I'm over here is because I have a ones place. The ones place is my label. This label tells me this is the ones place, and then after the ones is my decimal. So we have our ones, decimal, and then tenths, and then the hundredths. Thank you guys so much for joining. Thank you so much for joining. So we have 4, 9, 5, 6, 7, 8, 9. Thank you again for yesterday, for everybody being patient yesterday. I was out of my realm. I should have deferred it to say, you know what, that's not something I can work on. So we have 3, 1, 2, 3. This is 1, and then we have 2, 1, 2. The good idea, followers request you do a number on the abacus. Yes, yes. I have a few people asking, what are you saying about all the top ones? Oh, yeah. So if you're looking, the top bead, this is 0. Anytime the beads are touching the reckoning bar, it is being counted. However, when we count, we do 1, 2, 3, 4, and then what's after 4 is 5, but there's no more beads for 5. So to do 5, we have to do the top bead. Hello, thank you. Thank you. It is an abacus. It is an abacus. It is a counting tool. Thank you so much for commenting. Yes. And so, tap, tap, tap. Thank you, nom, nom. Tap, tap, tap. So when we're looking, we have 5. And then when we want to count higher to 5 and 6, right, we see that we can decompose. Decomposing means we can break up our number and we can see what numbers are composing it. So we have 6, we have 5 and a 1. So 5 and 2 is 7. 5 and 3 is 8. 5 and 4 is 9. So then you might be wondering, what is 10? 10 is this, because we have our ones and our tens. I'm sorry, we have our ones and our tens. So if we have a 1 in the tens position, what we're doing is we're representing our numbers on the abacus. And then we could do 20, 30, 40. How do you get 40? Well, 40 is a 4 and a 0. Easy as that. Easy, simple, super easy. I love it. Thank you. Oh, hey, Marcus, thank you so much. I learned to use this in China. Oh, good. Did you use the 2 and 5 or did you use a 1 and 4? That's my question. So the other question, or did you use the 10 bead? I don't think there's a 10 bead in China. So when we're looking, we have 50. This is 5 and a 0. So we're going to go back. Thank you so much, Lewis. Hey, welcome back, Lewis. Thank you so much. We're going to go back to understanding how to read our numbers. We have our 6,223. So when, I'm also learning acupuncture. Oh, that's really cool. But did you learn the 2 and 5 abacus or did you do the 1 and 4? That's the question. All right. So we have 6,223. When we're looking, we have 2 and 5. Okay, so that is very different than what we're doing right now. This is the Japanese abacus. This is the Chinese abacus. This is what Gerardo, right? Gerardo had mentioned. So when we're looking at it, this is the Chinese abacus, this is the Japanese abacus. Japanese came around and made the Chinese abacus more efficient because that's what Japanese people do. So in the Chinese abacus, we can count as well. We do 1, 2, 3, 4, 5, and then we count it, we trade this in, and then that would be the 5. So the top bead, the heaven bead, the top bead, the heaven bead is counted and we trade it in. So then we do 6, 7, 8, 9, and 10. We have 5 here, we have to trade it in, so that's 10. And then this gets traded in to this. So we have our ones, our tens, our hundreds, our thousands. It is very similar to the Japanese abacus. We do 1, 2, 3, 4, and then 5. After 5, we do 6, 7, 8, 9, and then 10. Yep, that's how it is. That's the difference between the two. Okay, so we have our number. We're going to do 6,000. That's 6. 5, 6. The top beat is a value of 5, and then we have 1. We have 2, 1, 2. We have another 2, 1, 2, and then we have 3. 1, 2, 3. For those of you that are interested, I do have this in my TikTok shop. Hey, Jeff, welcome back. Welcome back, Jeff. We're just looking at the abacus and we're just reading it. Do you remember how to read the abacus? So if I did 4,761, that's what we're doing. 4, 1, 2, 3, 4. Anytime the beads are touching the reckoning bar, it is being counted. So when you're looking, we were using 4 columns because it is a 4-digit number. Because it's a 4-digit number, we're using 4 columns. The thousands, the hundreds, the tens, and the ones. Did you know them? Myers is more. I don't know what that means. JJ, you're just mad that I can kind of freestyle. Oh my God, I was trying to freestyle math the other day. Whew, that one kicked my butt, but I think it was because I was tired. But now I'm okay. So we have 4,763. I'm sorry, 4,761. How is the size compared to the cell phone? Oh, so this is a 12. I think that's a 12. And so when we're looking, it's probably like that. And you can kind of fit it into your pocket. So it is something like 12 centimeters. Something like 12 centimeters. But, yeah, centimeters by 6 centimeters. Yeah, if that helps. I don't have a ruler for inches. I don't have a ruler for inches. I can't tell you what inches is, but if that makes sense. So, like 11.5 centimeters by 6 centimeters. Okay, good. Yeah, I know, like, sometimes it's like, it's deceiving because I only have this one. But then I have the other one, which is the 13 column abacus. And this one is 20 centimeters. This is 20 centimeters across, and again, it's still 6 centimeters high. So this is 20 centimeters big. Yeah. So this one is a little bit bigger. This one's the 13 column abacus. This one is a 7 column abacus. They both are made out of plastic, and they both work exactly the same. The number 0. Yep, that's the number 0. So when we're looking, we want to line it up, and it works exactly the same. Just one has more columns. So when we're looking, we have 1, 2, 3, 4. 1, 2, 3, 4. Then we have 5, right? Notice the top bead, the heaven beads touching the reckoning bar. And then we have 6. We have 6. We have 7. We have 7. 8, 8, 9, and then 9. And then 10 looks exactly the same. That's what 10 looks like. Size matters. Right, fish guy? Because size matters. Somebody asked me, what was a trillion, quintillion look like? And I'm like, really? It's just more numbers. All it would be just like this. That's all it would be. Like, everything else would be 0. There's nothing special to this. You know what I mean? Open your mind. Thank you. Back, teach. I know you miss me. I do, JJ. I do miss you. Thank you so much, Applesauce, for the reminder.
Open your mind to me, please. Open your mind.
Yeah, exactly. So, like, if I wanted to do trillion, but then I just gotta get a bigger abacus, so I don't understand what's the whole, like, special about it. So this is a 23 column abacus, but I don't sell this one. This one's my own. And when we're looking at it, I can't even fit it on the camera. So I'd be like, ones, thousands, millions, billions, trillions, quadrillions, and then over here. That's what I'd be, and I'd just do that. It doesn't even make sense. What would be the point? And even if I did make it like high up, you can't even see it because the abacus is so small. You know what I mean? Like, I'd have to do this and like, can you see it? I was like, no, you can't see it. I mean, that's ridiculous. Anyways, I don't think I'm going to respond to that one. All right. Back to work. Okay, for those of you that are interested, thank you for joining. Hello, my name is Lynette, and we are learning how to read the abacus. So, we have 3,000, 1, 2, 3. We have 598. When we're looking, the bottom beads is a value of 1, 1, 1, 1, right? And there's 3 of them, so that's why it's 1, 1, 1. The top bead is always going to be the value of 5. This is 5. So when we're looking, right? We have 9. Notice there's a top beat here, and then there's 4. 1, 2, 3, 4. We have 5 plus 1 is 9. And then we could do it again. 5 plus 3 is 8. Easy. Simple to use, easy to understand. And then here we go. Here's another one. So here's another example. 9292. What? That's easy, right? Because it's 9, 5, 6, 7, 8, 9. There's 2, 1, 2, 1, 2. And notice when the beads are not touching the reckoning bar, like this 5, these two, these bottom ones, then that just means that these are not counted. Oh, good, Adriana. Well done, well done. Or is it 1.2? Yeah, see, I don't, whatever. So, and then this is 9. This is 9. We have 5, 6, 7, 8, 9. Hold on, Dave. If you just sat back a little bit, it will be explained to you. Hold on. So we have 2, 1, 2. Again, when you look, these beads are not touching the reckoning bar. They're not holding hands. They're not singing Kumbaya, so they're not being counted. If they don't sing Kumbaya, then they're not going to be counted. So these beads are not touching the reckoning bar, so these columns are not being counted. This is a 4-digit number, so we're using 4-digit columns. We're using 4 columns as digits. Every column is represented on the abacus. So when we're looking, we have our ones, our tens, our hundreds, our thousands. Because it's a 4-digit number. So we know when we're looking, we have 2,313. So we do 2,000, 1, 2, we have 3, 1, 2, 3, we have 1, and then 3, 1, 2, 3. Now, if I added the 5, this would be 8. If I added the 5, this would be 6. If I added the 5, this would be 8 again. And if I added the 5, this would be 7. But I didn't add the 5. It's like that. So it's 2, 3, 1, 3. And that's all I heard. Oh, I see. That's because I was counting, Dave. I know I get a lot of those 6, 7s, and I don't know if they're trolls or not. But it is what it is, and we're gonna go to the next number. We have 1,000. I'm sorry. Yes, 1,001. I'm sorry. 1,810. 1,857. That's what I need to say. So we have 1,800, 5, 6, 7, 8. We have 5 and then 7. How do I know? Well, don't forget the top beat is a value of 5. When the top beat is a value of 5, 1, 5, 5, 5, right? These are counted. This one on the thousands column, this 5 is not counted because it's not touching the reckoning bar. So when we're looking, Peach, does this all make sense? We have 1 over here. This is 3, but because I have the 5, now we have 8. Because we know that 5 plus 3 is 8. And then 5, and then 7. 5 plus 2 is 7. Welcome, everybody. Welcome. Thank you so much for joining. Hello. How is everybody doing? What we're doing is we're learning how to read the abacus. If you're interested, this abacus is available in my TikTok shop. Thank you so much for liking the live. Okay. This abacus is made out of plastic. Hello, Yumi. Tired. I know, right, JJ? I'm so tired of that one. I fell asleep in your life. Happy to be back. Thank you, Joss. Thank you. Thank you so much for being patient last night. That was a little bit tough for me. Thank you so much for being patient. Oh, thank you, Glow Queen. Thank you so much. Thank you, Wendy Will. Thank you so much for checking in and giving roses. Thank you so much. Queen Glow, thank you. Hello, Lisa. Okay, anywho, I'm gonna head out. Okay, see you later, JJ. The dot gets people confused. The dot is just a label. So if you look, this is a label, and then this also tells you what the grouping is, or a period. So this would be the thousands. Why aren't you using the one? Oh, because I have a label right here. If you notice, there's a dot right here. Can you see that, Isa? Is K? Does that make sense? Do you see that dot? That dot tells me there's a label of ones, right? And then if I look, this is, I can't see it now. And then when I look, right? So this is our ones. And then we can have our decimals. We have our decimals. After the ones, we have our decimals. We have our tenths and then our hundreds. And that's it. I mean, when we're looking at it, right, we use labels for a reason. So it helps us position where we're going. And then if you look, this is our next label. This label here is our thousands. The 1,000 part, right? It's 1,000. That's what it is. So 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000. So Kelly, when we're looking, it's a 1 or 9,000. That's all it is. So I'm going to send it. Oh, thank you, JJ. When you, I appreciate you're just here, and I love the banter. I do have a view. I remember you. I remember how to use it. Good, 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 Adriana. I'm hoping it works well for you. I'm hoping that the abacus works well. Okay, at least when I first learned it. I'm sorry. The dot confuses the people. Oh, right, right, right. Right. The dot does confuse people because we don't label. But when you start being familiar, thank you for the follow, Queen Glow. Thank you, Prima, for the follow. Thank you, Maxwell, for the follow. But the thing is when we become familiar, it'll be a lot easier to see, right? But we're just unfamiliar because we don't know what we're reading here. Okay, are we ready? Are you guys ready to tell me what these numbers are? We're going to do the two-digit puzzles. Let's see how you guys do. This book is available in my TikTok shop if you guys would like. I do have it. It is called A Two-Digit Maze. And thank you, everybody. Thank you, everybody. I did sell out on the 3-digit maze. So now I got to go into the 2-digit maze, but I'm waiting for my shipment to come in for my 3-digit maze. It's just being slow. That's all. When do you go live? I would like to watch again. I usually go live. I try to go live usually at night around this time. Magpie, what? Thank you so much for commenting. So I try to go live around this time if that works for you. Does it work for you? Or is earlier better? Because I know there's the East Coast, and sometimes when I come on, it's like midnight mass. And I feel bad, so I try to get on earlier because I'm on the West Coast. Because I'm on the West Coast, I forget the time. Yeah, East Coast. Yeah. Okay, so I'm trying to come in earlier. I'm homeschooling, trying to teach my son. Oh, that's great. Hello, Ghost. Are you able to teach? Oh yeah, I was able to teach my cousin how to count on the abacus. That is awesome. That's awesome. It's fascinating when you could see the numbers. Okay, so homeschooling. I'm trying to teach my son. Oh, that's good. How old is your son, Magpie? Southern Oregon. Is that East Coast time or Central? I don't know my states. I apologize. I just know everything is East. He's 10. I would recommend a 3-digit or a 4-digit maze book. I don't have it with me right now. I am out of stock. But it is available over here if you are interested. And we will continue on learning how to add 5, take away the 5. Oh, and then also have a introduction to abacus for adults. And yeah, you could do that one too. He could do that. Wait, we talked about it, didn't we? I feel like we talked about that. Anyways, okay, so what are we doing? For those of you that are interested, let me know what number do you think this is. Didn't we talk about it, Magpie? I do have a book called The Introduction to Abacus for Adults. He might be able to use that one. Well done, Queen Glow. Yes, it is. 98. Well done. It is 98. Good job, good job, good job. What is our next number? So this is a 2-digit number. These are 2 digits, so I'm only utilizing these 2 columns. So what number do we think this is? Which is easy, right? Thank you, Juan. Thank you, Juan. Yes, it is 8. Well done, well done. Thank you, Donnie. Thank you, Fish Guy. Yes, what is our next number? So we have our 10s and we have our 1s. I can mute you again, Alex, if you don't behave. Or I can just block you because you're disrupting the class. You can call me a bully or you can just find your own live because I'm not for everybody. Thank you, Sarah. Thank you, Juan. Yes, 81. How do we know? We have 5, 6, 7, 8, and then we have 1. Well done. I'm not for everybody. If I was, then there'd be something's wrong. So, what is our next number? What is our next number? We have our 10s and we have our 1s. Yep. So we have our top bead is a value of 5. We have our bottom beads a value of 1. Good job, Magpie. Margie, sorry. Thank you, Margie. Thank you, Queen. Thank you, Juan, Elizabeth, and Sarah. Well done. 93. It becomes easier when you start looking at it, right? And it becomes more familiar. That's what we're doing. It's not difficult. It's just unfamiliar. Thank you, Alien. It's okay. I don't mind the trolls. Keeps me on my toes. Thank you, Elizabeth. Thank you, Sarah. Thank you, Juan. Yes, it is 78. Well done, Queen. Well done. So we have 78. When we're looking, we have 5, 6, 7. We have 5, 6, 7, 8. This is our 10s and this is our 1s. Well done. Well done. Whoa. Oh, yeah, there it is. 78. And so we have our next number. What is our next number? This is pretty good. This is good for, I would say, children that are maybe first grade, second grade. They already know their 2-digit numbers. And this is a maze. These are a bunch of mazes that go from 0 to 99. Thank you, Juan. Yes. So we have 8, 80, 5, 6, 7, 8, and then 4. 1, 2, 3, 4. Thank you, Gina, for the follow. Thank you, Juan. Yes, Elizabeth and Queen and Sarah. Well done. So we have 84, and then we have over here. Yeah, this would be for those children that already know their numbers and they're okay and comfortable with their single digits. I don't have a maze that is single digit because I feel like that would be more of an activity book as opposed to a maze. Yes, hey, Ashley. Thank you, Brandon. Thank you, Elizabeth. Hello, Nia. Thank you, Sarah. Thank you, Queen. Oh, wait. Oh, thank you, Joss. Yes. So we have 90. We have 3. Whenever the beads are touching the reckoning bar, this is the reckoning bar, right? This reckoning bar is what makes the beads count. Notice that these columns are not counted because none of the beads are touching the reckoning bar. So when we're looking, these beads, right, are touching the reckoning bar. This is the value of 5. This is the value of 1. And I have 4 of them. I have 1, 2, 3, 4. I have 4 beads. So together they make 9. 5 plus 4 is 9. And then we have 3. 1, 2, 3. I want to go. Oh, wait. Oh. I'm 24. I don't know. Wait. What? It's a quick recap. That was the quick recap. Link in adults. Link for the adults. Oh, it's here. And if you find my name, it looks like this. I should really heart this. Yeah. And it looks like that. Oh. So it's over here. If you want to DM me, I can send you the link. But it is over here. That's a good recap timing. Yes. Oh no, not yet. I'm bringing it in, but it's going to take at least a couple of weeks for it to stock up. So if you want to wait a little bit, I do have it available. But yeah. Okay. Yes, it is 93. We have 90, 5, 6, 7, 8, 9, and then 3. 1, 2, 3. Yeah. It takes about 3 weeks for it to come in. So when it's into the shop, I will let you know. Maybe I'll do a post when it comes in. All right. So our next number is, what is our next number? We have the top bead. Ooh, 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 no, Brandon. It is 50. It is 2. The 1 looks like this. That's what 1 looks like. 5 is the top bead. So when we're looking, it's the 5 on top and the 2 on the bottom. Thank you, Elizabeth. Thank you, Ashley. Kelly, what? So what are the what? Blue. Thank you, Blue Jay. Yes, 52. 52. So we have a 5 on the top and then 2 on the bottom. All right. And then that's what the 52 looks like. We have our next number is over here. So we have our 10s and our 1s. We have our 10s and our 1s. What number do we think that is? Thank you, Lizzie. Thank you. I'm too handsome for this. Thank you, Elizabeth. Thank you. Yes. So we have 38. It is not 100. It's not 100, Casey, because this here, if you notice, there is a dot. This is my label for the ones place. So when we're looking, it looks like this. So we have 30 and then our ones. That's what the ones would look like. So our ones and our tens. Over here is our decimal, because after ones, just like in regular math, after our ones, there will be the decimals. We have our tenths and our hundredths. Thank you, Eric. Thank you. Does that make sense, Casey? So when we're looking, we pay attention to this label. Yeah. But you almost got it. That's well done. So what is our next number? Oh, you can't see that. Hold, please. Hold, please. There we go. There we go. There we go. There we go. Oh, it's not dead yet. Okay. Yes. So we have our next number. We have our tens, and then we have our ones. Almost. I'm too handsome for this. It is 30. We're not rounding up. We're not rounding up. We are talking about exactly the exact number. We don't need to round up. We're not rounding up. We're not practicing how to round up. All right. Thank you. This is really interesting. Thank you. I never knew about this. Thank you, Eric. Thank you. I appreciate that comment. Okay. Thank you, Elizabeth, Lizzie, Juan, Casey, Joss. Yes. Thank you, Queen. Okay. Yes. It is 39. What's the next number? The next number is... Remember, the top bead is a value of 5. So we have our number. What is our number? We have our ones and our tens. That's what we're doing. That is what we're doing. Hello, everybody. Hello. Yes, it is 94. That's well done, Elizabeth. Thank you. Almost. I'm too handsome. It is 94. We have 5, 6, 7, 8, 9, and then we have 4. 1, 2, 3, 4. Notice that the top bead is not counted on this column, the ones column. So this is not counted. So we have 90 and we have 4. Well done, well done. So then that's 94, and it takes us to our next one, and we are done. Woo! What is our final answer? Thank you, everybody, for joining. Thank you so much for joining. Which ones? This is the ones. This is the tens. So when we're looking, Mike I. Kim. When we're looking, we have our ones, because there's a label right here. This is my ones, and then this is my tens. You know, whatever's left is the tens. So we have our 30, and we have 6. Well done. We have 1, 2, 3 in the tens column, and we have 6. 5, 6. The top bead is a value of 5. The bottom bead is a value of 1. Together, it makes 36. Well done. Well done. Well done. Okay, so that is this book right here. I do explain a little bit more in the beginning on how to read the abacus. And what we do is we talk about from the numbers from 0 to 9. And then I talk about like the single digit, and then I start introducing the double digits. So the double digits just means like it's 10, 11, and 12. So on the abacus, we do 10, 11, 1, 1, and then 12, 1, 2. When we're looking, this is just a review, just in case it's been a while since we were in school. I just explained how the tens and the ones look like, and I just break it up. So this was a little review on what the tens and the ones placement value, and then I give you this mask maze. This mask maze is what I have been covering the paths. The reason why is because the answers are on the path, and it's very easy to see what the answer is. So I give you this opportunity to download the mask maze, because I feel like that the paper in the book is a little thin. So I give you the opportunity to download it, and then you can use it on, and you can print it out, and you can use it on any other item that's a little bit thicker. Thank you. I'm too handsome for this for the follow. So that is why I have a mask maze, and this one specifically I'm using is a file folder, and I just cut it up. And that's what we did. We did the first maze, and then and then there's another kind of maze. It's called a reverse maze. What it means is I have instructions to tell you that what you're going to do is you're going to start here. You have the number. I give you the path, and you need to color it in. That's all that is. Thank you. No, thank you. I appreciate the comments and activity. And so when we're looking, here, because I've already done it, right? So the question is what is this number? This number is 54. What does it look like when you color it in? That's all it is. So you take the number and I show you what the path is, and then what you have to do is you have to color in the abacus. So I kind of like this, and then because I like using marker, it's it's only one-sided, but it's because it bleeds through. Yeah. And I was using what was I using? I was using a highlighter as well. It still bled through, so I don't like it how it bleeds through. But that's what it is. And if you're ever wondering, I do have answers in the back of the book. Thank you so much for everybody for joining. Thank you everybody for joining. So this book itself is the 2-digit mazes. This one's really recommended for people who want to practice their 2-digit numbers on the abacus. And it also comes with an abacus as well. But we're only using the 2 digits, 2 columns. That's all we're doing, and we're recognizing it. So I was kind of thinking that maybe the kids that are maybe like high-end kindergarten, first grade, second grade, because they start doing double digits. Third grade, I think, is a little bit easier. I think it'd be a little bit too easy for third grades unless they need the extra help. And then I do have a 3-column and a 4-column, but I'm still waiting for the shipment. It might come like on Friday. I'm not sure. We will see. So, how are we doing? Thank you everybody for joining. What we're going to do now is we're going to understand how to move the beads. What did we just do? We just learned how to read the beads. So I have a whole thing. For those of you that are interested, we just learned how to read the beads. Read the abacus. Now what we're going to do is we're going to understand how to move the beads. Moving the beads is very specific and very interesting. Is it really interesting? It is pretty interesting. Because once you learn how to move the beads, then I'm going to start teaching you concepts of how to add, subtract, multiply, and divide. But the first thing we need to do is understand how to move the beads. When you look, the beads are edged. Because it's edged, you want to be gentle when you move the beads because it's very easy to move. Thank you so much for checking in. Thank you so much, Queen, for checking in. So what we're going to do is we're going to be not aggressive and don't flick.
And flick. Oh, you flicked too hard, damn it!
Don't flick, because if you flick, you're going to get the wrong answer. So what you want to do is you want to be gentle and you want to be intentional when you move the abacus. That's it. Right? So thank you everybody for joining. Thank you so much for joining. Please keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
I can't say something new because abacus has been around for centuries, like way back in the Mesopotamia. So it started off with Mesopotamia, like before Christ, and then it went to, then somehow China got to it, and China made it into a frame, and then now the Japanese came around, and they said, I'm going to make it more efficient. So the Japanese came around and made it more efficient. So, but yeah, the abacus has been around for many, 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 many years. All right, and so thank you everybody for joining. Thank you everybody for joining. I'm here to show the Matrix what an abacus is.
Welcome to the real world.
So again, what we're going to do is we're going to understand how to move the beads. Here is another book. This book was meant for preschoolers. The reason why was because I wanted to get the kids young. In Abacus world, we were neglecting I felt like we were neglecting the young children, and I feel like, I would feel like we were neglecting the young children. So I made activities all about how to recognize the number, and what it means to have it, tracing and stuff. And so I wanted to be interactive, and I wanted to be engaging. And so I mean these are just activities for the kids to get them interested in what an abacus and how to count. That's all it is. We're just counting. So this is lesson 2, and lesson 2 just goes from 0 to 5, 5 to 9, and then we count forward, we count backwards, and then after we count backwards, we figure out what comes in between. and then we figure out what counts between, what becomes if I've returned. Hello, Mr. Clean. Welcome back. Hello. I just ordered 2 books to get the abacus I really enjoy. Yes, thank you so much, Sarah. What are we doing? Oh, And then we talk about comparing, and after comparing, now we're going to talk about how to add. There's so many people. I know, right? It's crazy. And I appreciate every one of you guys. I'm so happy there's so many people that are interested in what the abacus is, right?
Now, open your mind to me, please. Open your mind.
I have different sound bits than all the other regular people, but thank you so much. Okay, Mr. Ashley's here. Yes, Mr. Clean. Do you see Ashley? So, thank you everybody for joining. What we're going to do is, in the abacus world, what we do is we focus on the second number. We're ready to start adding and subtracting. We're moving the beads now. Did you show how to divide it? I no coconut water? No, I don't. I drank all my coconut water. Actually, no, I didn't drink coconut. No, I still have other coconut water and it's flavored. But that one specifically, I finished. I gotta buy more. Okay, I did show. Did I show it? I don't know if I did, but we can try to get to it depending on how far we get. Yeah, is that all right, Joss? Yeah, it'll be easy. I was trying to figure out another way because they were talking about how it's kind of difficult to see the difference, and I don't know. Okay, but yeah, let's see what we can do. Let's see what we can do. I think it's going to be good because there's not a lot of questions. If there's not a lot of questions, then I go through and I start running through everything. Okay. So, in Abacus world, we focus on the second number. When we focus on the second number, the question is, do I have enough beads? So I have 7 on the abacus, 1, 5, 6, 7. I have 7 on the abacus. I'm going to add 1. When I add 1, do I have enough? Can I do it? Yes, we can. We can add the 1. So my final answer is 8. We have 5, 6, 7, 8. So when we're looking, we're just making sure that we can add it. We're not focusing on the result. We are focusing on the process. So what you want to do is you want to marry the process and divorce the result. When we're looking, I just came by to say hello. I got to, okay. Oh yeah. Yes, Mr. Clean, you need to get ready for school. Better be on a better schedule, right? I got to get my kids on a better schedule because they're going to start in 2 weeks or night. Have a good, yeah, it's still night. It's like, it's 9 o'clock for me right now. I am in Southern California. Yeah. When do you start school, Mr. Clean? Oh, I don't know if you left, but yeah. Do you start school in 2 weeks? My kids start school in 2 weeks. Okay. So we can do it again. Around September? Ooh, that is late. Lucky you. So, okay, have a good night, Mr. Clean. 2. So, we have our number. We have 5, 6, 7. And again, I want to add 2. Notice I have 2. Do I have enough? Yeah, I have 2 right here. So all I'm going to do is add the 2 beads. That's what I'm doing. So my final answer is 9. But when you're looking, it doesn't matter which 2 beads. If I have 6 here and I want to add 2, that's all I'm doing. I'm adding 2. Have a good night, Mr. Clean. If I have 5, right, I want to add these 2 beads. I'm just going to bring up these 2 beads. That's it. So we have 5, 6, 7. That is 7. So here I have 7 on the abacus. I want to add 2 beads. These are the 2 beads I'm adding. So my final answer is 9. And that's it. And then here is 5 plus 3. Again, we do 5 and then we do 3. 1, 2, 3. In mainstream, you could do dots, which is fine. You could do dots, or you could do tally marks, which is fine too. But in Abacus world, we don't need to, right? We just need to remember that this is the top bead, which is 5, and then 3, right? And then we can actually scale it. If I want to say 50, 50 plus 30, 1, 2, 3, I get 80. You could do dots. That's a whole lot of dots, and that's a lot of counting. I don't like to do all that counting, but it is up to you. But the other one is, right, we can do 500, 500 plus 300. 1, 2, 3, 300. So our final answer is 800. 8, 5, 6, 7, 8, 0, 0. There we go. All right. So then what's our next number? Our next number is 4. Notice that when we go to the horizontal bar, we're adding 4. When we want to subtract the beads, we just go away from the horizontal bar. That's all we're doing. So if you notice, when I take away 1, I don't take away from up here. I take away from down here. All I'm doing is taking away the 1 bead. So that's the one thing I noticed that people are getting a little bit confused about, because they think that the colors mean something. The colors actually don't mean anything. So if I have this, I'm just going to move the brown bead. So So if I have 4 on the abacus, I want to take away 1. I'm just removing the 1 bead. I could do it again. If I have 3 on the abacus, I just want to move the 1 bead. That's all I'm doing. And it's again if I do 2. So if I have 4 on the abacus, I want to move 2. I just move these 2 beads. That's all I'm doing. And don't forget, I'm going away from the horizontal bar. When I go away from the horizontal bar, right, I'm subtracting. So if you notice, if I know how to add, I will know how to subtract. I add 3 on the abacus. I want to take away 2. When I take away 2, I'm just removing it away from the horizontal bar. Thank you, everybody, for so much for liking the likes. Liking the live. We're at 11,000. That's pretty awesome. Thank you so much. Thank you so much. So again, we have 3 on the abacus. No, we have 4 on the abacus. Ooh, 4. 1, 2, 3, 4. And then we want to take away 3 again. When we take away 3, it's just these 3 beads. That's all we're doing. We're just moving it. That's it. Can you 97.1? That's it. I can do it again with this one. Thank you, Casey. We have 97.1. That's a very valid question. Does that make sense? Yeah? You all right? So when we're looking, that's a really valid question. No, thank you. Better than 6, 7. When we're looking, this is the ones, because you see there's a dot here. This dot tells me is the ones place. So we have our ones, our tens, and then after the ones is our decimal. So our decimal sits right here. Yep, not a problem. That's a very good question. Very valid. Thank you. Thank you. I appreciate that. I'm just adjusting my camera now. All right. So then after 5, right, notice if I have 3 on the abacus, I'm going to add 5. To add 5, I just need to bring it down to the horizontal bar. That's all I'm doing. So when I take it away or I add, that's all I'm doing. And if anybody's interested, it is this book over here. I only have one left. I got to bring up my stock. Okay, so we have 5, we take away 5. Add the 5, take away the 5. And then it's the same thing with the 6. I have 2 on the abacus. I'm going to add 6. To add 6, I bring it together like that. When I take away 6, I push it apart. So you're going to see a number pattern. I add the 6, I take away the 6. And what we're doing is we're just moving the beads. If I need to add the 6, I just bring it in. If I take it away, the 6, and I move it away from the horizontal bar. So they're all singing Kumbaya. As long as you're touching the abacus, as long as you're touching the reckoning bar, everybody's singing Kumbaya. And if they're singing Kumbaya, then they're all being counted. If you're not touching it, then you're not part of the in group. So we have 8. We have 1 on the abacus. I want to add 8. This is what 8 looks like. 5, 6, 7, 8. We bring it together like that. We want to take it apart. We want to bring it together. That's all we're doing. So it's just a matter of moving the beads to match whatever we're trying to do when we add and when we subtract. So if you go from 4 from the line and bring down, yes, so you have to take all, if you add the 5, you have to take it down. So you have to remove all the 4 beads down. Yes. So that's the only thing, is you have to know that when you have 4 and you want to add 5, you have to subtract the 4 and add the 5. That's what 5 looks like. Because after 5 is 6. So we have 5, 6. 5 plus 1 is 6. The 5 is what makes it go above 4. Does that make sense, Casey? So we have 2, and when I add the 5, we have 7. If I have 1, 2, 3, and I add the 5, we have 8. We have 4, we add the 5, now we have 9. So it's this 5 that really pushes everything to the higher number. Good. Good. So now the question is, what happens when there's not enough beads, right? We have it where there's not enough beads. What's 10? 10 looks like that. Why? Because our 1s and our 10s. Hello. Hello, Justin. Does that make sense, Dave? It's like counting with 10 sticks and 1 block. Kind of, but that's a 1-to-1. What is the abacus useful for? It is for counting, adding, subtracting, multiplication, and division, as well as for understanding number sense, number flexibility, and number flexibility, number sense, and number fluency. I think that's what it is. For kids, it's kind of comparable to the cubes, right? To these little cubes. It's kind of comparable to the cubes. But there's more to it because there's critical thinking involved, and we have formulas that we need to memorize. As opposed to mainstream, there's a whole lot of stuff to memorize. Hello, Maddie. Hello, welcome, welcome, welcome. So, if it's for older people that have kids or kids are older, then if you enjoy puzzles like Sudoku, crossword puzzles, jigsaw puzzles, chess, then you'll enjoy Abacus because Abacus is just adding, subtracting, multiplying, and dividing. And you can do a lot with that. And the questions do get more complicated, so there's critical thinking involved as well. So that's the other thing is Abacus is really good at teaching the... Abacus is really good at sharpening your critical thinking skills. What about your adult book? Just interested. I have an adult book. It is available over here. It's available over here. It's not in my shop yet, but it will be. If you want to wait or if you want to buy it now. It is up to you. I need to find my paper. Here it is. It is available here. If you want to buy it now. But if you want to wait to get to the shop, then it's going to come in like 2 or 3 weeks. I apologize for the delay. So, 10 dots make 1 stick. Thank you, Mr. A. That's what they use in elementary. This is like that, but aren't small to lose. Yes, exactly. So, but the difference is the blocks is a 1-to-1. It's still a 1-to-1. Whereas the abacus shows you representation. So, if I had 3 sticks, right? 1, 2, 3, that's still a 1-to-1. As opposed to, I have 30 on the abacus, right? I could do 80. I could do 80, but it's still 1-to-1. What does that mean, 1-to-1? Well, I have 1 stick, 2 stick, 3 stick, 4 stick, 5 stick, 6 stick, 7 stick, 8 stick, and then 9 stick. Right? I have 9 sticks. But on the abacus, it's a representation. Hello, me! Thank you. I appreciate my stream too, me. That's funny. So, this is still a 1-to-1, which is very different because in the abacus, it is a representation. You could do 900, but then there's going to be a whole lot of these little, whatever these are. 900. I gotta get 900 of these. And then it gets unruly. Because if you think about it, right? If you have 26 students and they all have their own, I don't know, their own bricks, you have to count it. Like, how do you know what number this is? You have to count it. I have to count it one at a time. 1, 2, or you can group it, right? You can group it. You can do this. You can group it and try to figure out. It's like, oh, it's still 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12, right? But on the abacus, 12 or 120. It's easier to see. You could subitize this is 120. Why? Because every column is represented. We have our ones, our tens, our hundreds, and our thousands. So if I gave you all of this, do you know what number this is? No. You would have to figure it out one by one. So it'd be 1, 2, I don't know, whatever, right? But that's the difference between the bricks and the cubes and the sticks and the dots, because the dots and the cubes, and they're all 1-to-1. Whereas on the abacus, it's a representation. All right. So, thank you, Mr. A, for the comment. But that's the difference. It's a representation as opposed to 1-to-1. So now we're going to get into what happens when there's not enough. Amaya, what's wrong, Amaya? What's wrong? Where's my book? Oh, here it is. Okay. So, what are we doing? Kind of interested it works. Oh yeah, decimals is just a placeholder. right? So we have our decimal. We have our decimal right here. It sits between our ones and our tens. So we have our tenths and our hundreds. Yeah, yeah. And then if you choose, and then depending on if you want to use, so if you notice that there's two labels, right? One label is here, one label is here, and then it's a period. It's a grouping. So we have our ones and our thousands. But then, what if you want to choose this one? What if you want a bigger or smaller number and you want to change it to a decimal? You can choose this one over here like a Pokemon.
Pokemon, I choose you!
So all you do is just move it over like this. So then you have your ones and your tens. Just like that. So then it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. So then what does that mean? Well, that means that I can do a really small number. I need, right. So if I do 2, right, there's a 2.00001. 00001. You could do that. Hello, Daylin. Welcome back. Thank you, April. Hello, April. How are you doing? Okay. Does that make sense? Me? So, depending on where your decimal is, right? Depending on where your ones is, I would label the ones. That's what I do. I label the ones. It's a guideline, right? And then you'll see that this is my ones, tenths, hundred, thousandths. Right? And then this would be 10,000ths and then 100,000ths. So that's what this would be. Yep. Cool. Here we go. So April, thank you for joining. Just to do a review for those of you that just joined. Hello, everybody. Hello. 15,000. All right. So we're going to count on the abacus. We do 1, 2, 3, 4, and then 5, 6, 7, 8, 9, and then 10. Whoa, that's 10. Because we have 1 tens here, and then there's a 0 here. We can count 11, 12, 13, 14, and then 15. That's it. So we have 16, 17, 18, 19, and then 20. Now we can count by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, and then 100. What are we doing? We're representing numbers here. We're representing numbers. I was never good at math. That's funny to say because I am a fabrication welder. That's very interesting. I don't know what a fabrication welder is. I'm assuming it's definitely above my pay grade. It's definitely above my pay grade. I would have to look that up. So when we're looking, we're visualizing numbers. That's what this is. The abacus just helps you visualize numbers. So we're going to count 1, 2, 3, 4, and then 5. That's it. And then we have 6, 5, 6. 5 plus 1 is 6. 5 plus 2 is 7. 5 plus 3, 5 plus 3, 1, 2, 3 is 8. This is 5. The top beat is always 5. And then we have 4. 1, 2, 3, 4. 5 plus 4 is 9. That's it. Okay, so now here's the question. The question is what happens when we don't have enough beats? Well, if we don't have enough beats, guess what we're going to do? We're going to use a formula. This is one of the things that we need to understand. This is a concept. We're going to do some applied logic. We're not going to memorize. We're not going to do rote memorization. We're not going to just memorize 4 plus 4. What we're going to do is understand how to utilize the abacus, right? So the question is 4 plus 4. When I add a 4, what can I do? I can't do anything. I don't have enough beats to add the 4. And if I do that, that's just 44. We're not doing 44. What we're doing is we need to add the 4 to the ones place. That's what we're trying to do. So when we're looking, we need to add 4 over here, not here, because that's the tens place. This is the ones place. So what do? Well, I have 4 on the abacus. 1, 2, 3, 4. We know this concept. This concept is 4 plus 1 is equal to 5. What does that mean? Well, I have a nickel. If I want to have 4, I get a nickel. Because I have a nickel, I'm going to give you my nickel, but that's too much. I'm going to expect some change. So what's going to happen is I need to take away 1. So my final answer is 8. 5, 6, 7, 8. I could do it again on the abacus. I can add the 5 and take away the 1. So my final answer is 8. 5, 6, 7, 8. It's just like in cars where you have to go left to go right.
If you're going hard enough left, you'll find yourself turning right.
Oh, right. That makes perfect sense. Turn right to go left.
So what did we just do? We subtracted to add. We could do it again, and we're going to practice, right? We have 3 on the abacus, 1, 2, 3. And then what do? We give you the 5, but that's too much, right, April? I give you the 5, that's too much. I need to take away the 1. So my final answer is 7, 5, 6, 7. On the abacus, I add the 5 and I take away the 1. Yeah, because I have to subtract in order to add. I need to take away, because I given you too much. It's a, what do you call, somebody mentioned it was over, I give you a little bit too much. That's what it is. I give you a little bit too much. So I need to get back some change, right? Just like a package. If I had a package of 5 avocados, right? If I have a package of 5 avocados, but I only need 4 avocados, I need to get rid of this one here. To get rid of it, I need to take away the 1. Oh, take away the 1. Why do they make like it makes sense, but just put your fingers. You could do your fingers. But that's counting up, right? 1, 2, 3, 4, 5, 6, 7. You could count up. Or you can understand the concept of, if I have 3 on the abacus, right? 1, 2, 3. And I don't have any more room on the abacus to add another 4. I don't have any room to add 4. What do? I critically think that I can utilize this 5. But notice in the 4, 1, 2, 3, 4, I have it here. What are we going to do? We have to get rid of this 1, but it's all attached. I need to open up my package and just take away the loose 1. So I take away 1. So I can add the 5, but I need to take away the 1 because I don't need the 1. You know what I mean? So my final answer is 7. 5, 6, 7. So what are we doing? We're trying to work with the constraints of the abacus. You could count up. You could. That's a whole lot of counting up. And that's what mainstream math does. Mainstream math counts up. Mainstream math you have to memorize a lot more. But in abacus, you don't have to memorize a lot. There's only two things that you need to do. You need to memorize how to make a 5, and you need to know how to make a 10. If I can find mine. And you need to know how to make a 10. Those are the only things you need to memorize. But in mainstream, you have to figure out how to add a 9. You have to figure out how to add an 8. And there's a whole bunch of others. But in abacus, you only need to know how to make a 5 and how to make a 10. And then because you know how to do everything revolves around this. So let's say in mainstream, there was this one where I was watching this video. And they're like, you need to memorize how to make a 9. Why do I want to memorize this? It doesn't make sense. So on the abacus, if I want to add the 1, I know all I got to do is add 8. I don't need to memorize that. In mainstream, I need to add the 2. I need to know that 2 plus 7 is 9. I don't need to do that in abacus. I just see my beads. If I look at my beads, I have 3. I want to add 6. That's all I'm doing. I'm adding the 6. To make a 9, I'm adding 6. I don't need to memorize it because I know that this is 9, right? I know if this is 9 and I want to take away the 3, I have 6. I don't need to memorize it. I have 4. I want to add the 5. I don't need to memorize that 4 plus 5 is equal to 9 because that's what we call simple. In abacus world, this is called simple because everything is all ready for you. You don't need to worry about formulas. It's different when you have it when you don't have enough beads. And this is why we start talking about formulas, because now we're critically thinking what we're trying to do. So here you could memorize 3 plus 3. Thank you for sharing the for 9. That unlocked the concept, right? It's crazy. There was like a whole bunch of other there's a whole bunch of other concepts that we are told to memorize, but you don't have to on the abacus. You just need to know your second number. That's all you need to know. If you know what you're doing here with the second number, we're not focusing on the result. We're focusing on the second number. We're focusing on our add-in or our subtracted. We're focusing on the thing that we're trying to do. And that's the other thing that abacus does, right? In mainstream, there's a lot of like, we're going to count up to whatever, and we're going to make it, and then you have to remember in your brain that you did this adding. But in abacus, we actually utilize what we have. I was just at a computer history and figured the abacus out. What? Trying to figure out the abacus. Oh, I see. Trying to figure out the abacus. It's amazing. It's the simplest and elegant tool. It's so simple and elegant. It's very elegant. So let's do a review. 1, 2, 3, 4, and then 5. The top beat is always a value of 5. We have 6, 7, 8, 9. Line What kind of abacus was it? Was it a 10-bead abacus, or was it a 2 and 5, or was it a 1 and 4? So I wonder what kind of abacus you saw in the exhibit. Can you let me know? Because sometimes they only show the 2 and 5. Sometimes they show the 10 beads. Very rare do I see that they show the 1 and 4. Because what I'm talking about is a 1 and 4, which is a Japanese abacus. This is a Soroban. It had 10. Oh, yeah. Okay. So 10. Yeah. So the 10 bead is a 1-to-1. And they didn't start talking about formulas. What I'm teaching you now is a concept. So it's the same thing, but it's just a 1-to-1. So we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's it. And then you just count it. It's just, that's all it is. It's just counting. One beat at a time. That's all it is. But this is a little different because we have representation and you could see it, right? You can see that this is 9. How do I know? Because this is 5, 6, 7, 8, 9. This is a Soroban. This is a Japanese abacus. And we could do it again here. So what we're doing is we're understanding the concept. This is much better as a beginner. Thank you. Oh, yeah, for sure. You make... Oh, good. Thank you, me. Hello, Fairy. Do you know how to use the abacus? Because that's where my dad got the idea from. He went to Korea, and this lady has a child that was autistic of some sort, and she was like, you need to bring abacus to America. And my dad's like, I'm going to bring abacus to America. And I'm like, what? What is an abacus? I'm like, why? But as I started going through this journey of learning what an abacus is, I feel like it's the greatest thing next to sliced bread. And I do appreciate learning abacus. I didn't learn abacus when I was a child. I actually learned abacus when I was a lot older. So, Fairy, do you know how to use the abacus? So for those of you that just came in, thank you so much for joining. What we're going to do is we're going to count. We count 1, 2, 3, 4. Every bead at the bottom of this reckoning bar is value of 1. Anytime the beads are touching the reckoning bar, it is counted. So we have 4. 1, 2, 3, 4. These columns, you used it in school. See, that's what I'm trying to do, is I'm trying to show the matrix how to use an abacus. Did you do all the way to multiplication and division? Thank you, Fairy, so much for joining. Thank you so much for joining. And then if I want to do 5, that's what 5 is. 5 is the top value, the top bead. We could call it the heaven beads if you want to be poetic, and the bottom beads is considered the earth beads. So we have our 5, and then we have 6, 7, 8, 9. And then we have 10. 10 looks like this. 1 and a 0. That's it. That's it. 1 and a 0. So when we're looking, we have our place values. We have our 1s, our 10s, our 100s, our 1000s, and our 10,000s. What right called do you use them? Decimals. Decimals. These ones, these two here are the decimals. So we have our 1s. The decimal sits here, right, between the 1s and the tenths. This is the tenths, and then this is the hundredths. That's what a decimals is. Because this is a decimal, this is base 10. Yep. This is a base 10 because we're doing decimal system. So this is a representation. Both my parents are math teachers, yet they didn't get to teach me. I don't know how many math teachers know how to use the abacus. I'm just saying. There's no judgment, but I don't know how many math teachers know how to use the abacus. An abacus is just a different tool, and it's not very common in America. It's not very common in the matrix. All right. So we have 4 on the abacus. We have 4 on the abacus. And what are we going to do? Again, the concept is if I have 3 plus 2 is equal to 5. If I need to add the 3, if I had a hammer, if I need to add the 3, I don't have any more beads, right? 1, 2, 3, 4, right? That's what I have. 1, 2, 3, 4. But I have no more loose beads. Because I have no more loose beads, I cannot add the 3 to this column. But I have this 5. I have a nickel. If I give you my nickel, I gave you too much. I need some change back. I need to take away 2. So this is why it's good to know your math fact. 3 plus 2 is equal to 5. Because I added the 5, I need to take away 2 because I want to just add the 3. I could show you again on my abacus. I add the 5 and I take away the 2. My final answer is 7. 5, 6, 7. And then we could show you again. If I have 3 on the abacus and I have 3 cubes, no, 4. I want to do 4. That's what it was, 4. right? I have 4. But I want to add the 3. Guess what? That's what this is. This is the top bead. The top bead's worth 5. I don't have any more random beads, right? So I can utilize this package, but this package is all 5 cubes all stuck together. Because the 5 cubes are stuck together, 1, 2, 3, 4, 5, right? They're all stuck together. I only need to use 3. Because it's 3, 1, 2, 3, I need to get rid of this. I need to get rid of these 2 cubes. But because they're all stuck together, I don't want to take it apart from the 5. What I'm going to do is I'm going to take it away from the previous number because these are loose. So I just take away 2 like that. I take away 2 like that and I add my 5. So my final answer is 7. 5, 6, 7. That's what it is. 6, 7. Thank you, me. Thank you, tortellini off. That's what it is. So we have 7. 5, 6, 7. Yep. So we can do it again with the 6. Again, we're not going to memorize. We're not going to rote memorize 3 plus 3 is 6. We're not going to do that. What we're going to do is we're going to understand a concept. The concept is if I want to add 3, I have no more beads to add the 3. That's what we're doing. Hello, Sarah. Thank you, Sarah. Right? Yeah, I think the packages really help. So we add the 5, and then we take away the 2. 1, 2. So my final answer is 6. I could do it again with my abacus. I can add the 5, take away the 2. You know what? You're absolutely right. They did make math more complicated with all the memorization that they have to do. Those poor kids. Those poor kids. I feel so sorry for them. I don't know why they need to know. Why do they need to memorize? Why do they need to memorize? I'm not understanding. Thank you, Danica, for the comment. I know, right? Why do they have to memorize? I don't understand it. Like, there's a whole thing. It's so crazy. Even like this, even like with the number bonds, they have to memorize that 16 is equal to 9 and 7. You have to memorize that. Why? Or you need to memorize that 9 and 8 is 17. Why? Hello, welcome back. 8, I see you. We're doing pretty good. The trolls are not trolling too much. Hi, SD. So yeah, they have to memorize that 9 plus 9 is equal to 18. Why? Why? I don't know why. I don't know why they have to memorize 9 and 6 is equal to 15. Why? Right? As opposed to in Abacus, you just understand the concept. You understand the concept of, because it's easy to memorize, but that's why we call it illiterate. There's that one movie I was talking about, The Truth About Reading. Where did I put it? The Truth About Reading. The Truth About Reading explains exactly how people become illiterate. There's this one English teacher. It was crazy. This English teacher was illiterate. He even had a master's degree, and he's illiterate. How is that possible? Memorizing everything, right? That's so much work. That's so much work. If you understand the concepts of making a 10 and making a 5, it will make your life in math so much easier. And then there'll be more room in your brain to think about more complex math like algebra, geometry, trig, calculus, and all the other finite math, right? So, yes, you're right. I don't know why mainstream math wants all the kids to memorize all this stuff. It's crazy. It's so crazy. You're absolutely right. Oh, anyways, 5 times 2. I'm sorry. I wish I was that smart. Yeah. I don't know if it's smart to memorize. That's like crazy. I'm really lazy. I don't even want to do all that memorizing. It's so much. It's so much memorizing. Anyways, so why didn't I know this before I was 5 times 2 equals to 10. Thank you, SD. Can you do a multiple? You want to do multiples? We could do it. I mean, are we ready? But the problem is then you don't know how to make a 10. Do you understand how to make a 10? We could do multiplication. It will be easy multiplication because I'm going to show you a concept. If that's okay. You want me to show you the concept of multiplication? I could do that. That's not a problem because it's easy, simple to use, easy to understand. I helped a friend to get her master's. She couldn't write a paper. Oh my God! See, Lady E. Show the concept. Okay, I could show the concept. Again, it is very easy. It is a very easy. You can definitely do it in your head, but again, the caveat is I am showing you the concept, just like these ones, right? We know that 4 plus 4 is 8. We know this, but I'm showing you concepts. And what I was doing is I was showing you how to make a 5. So now we're going to jump ahead. All right, we'll jump ahead. I don't know why everybody's so obsessed with multiplication. This is why I got to bring out my multiplication. I got to bring out my multiplication book faster. Yeah. I got to get my multiplication book out the door so you guys can do it. Do it. And then help the kids to do multiplication because I know the kids are having problems. And it's sad. I mean, you do need to know your multiplication table. You do need to memorize that. That is hands down you need to know. But in Abacus World, what you can do is you can do repetitive addition. You could do that. And knowing how to do the repetitive addition on the Abacus will help. Okay, so the first thing we're going to do on the Abacus is understand where we're going to put our number. Right here. There we are. So what we're going to do is we're going to figure out where to put our number. The reason why is in mainstream math, which is really crazy, they don't tell you that you can actually look at the question and be like, oh, this is going to be a 3-digit number. Kinda, right? So you want to do a 3-digit number. Well, why do we need to know that? Because then we know where to put our answer. 1, 2, 3. 1, 2, 3. That's what we're doing. Why are we doing that? The reason why, if I can get a pen, the reason why is now we can multiply it out. What we do in Abacus World is we do distributive property. Distributive property means what? Distributive property means breaking the numbers into smaller parts. That's what we do in Abacus World. We multiply the parts separately. Thank you. I am bored. Yes. So we do 1, 2, 3. Do you see that? 1, 2, 3. So now we're going to multiply it out. 8 times 1 is 8. Lynette, you lied. It's supposed to be 3 digits. I know. But look. If I need to, because it's a single digit, I actually need to make sure that I have to remember the leading 0. This leading 0 will push my answer to the next column. It's got to push back. That's what I got to do. This 0 will help me push the number back. So I have 8 on the Abacus, right? And then we do 2 times 8. 2 times 8 is 16. We add the 1. Thank you, I am bored. And then we add the 6. So my final answer is 96. That is the concept. That's it. So what we just did, thank you, I am bored. So that was what we did. And we did it on the Abacus. You could do it. Yes, I know you could do it in your head. But this is just a concept. So even if this is it, right? We do 3. 1, 2, 3. 1 times 1 is 1. 1's a single digit. You add the 1. Do it again. 1 times 1 is 1. 1's a single digit. You add the 1. So my final answer is 11. I don't get it. You don't get how to get the number? Or you don't get what I just did? So here we go. We count 1, 2, 3. We need to know that our answer is going to be in the hundreds column. That's it. That's all it is. So when we know that the number is our column, we're not going to do 60 times 70. Because if you look, 7 is our multiplication fact. So 6 times 7 is 42. Add the 4, add the 2. So I add the 4, add the 2. Notice it's actually 420. Because why? The Abacus tracks my placeholder. I have a 4 and I have a 2. And that's what I did, 42. So my final answer is 420. Let's do it again. My next number. Okay, we know 1 times 1, but this is the concept I'm showing you. I'm just showing you how to do it. So we do 1, 2, 3. Why? Because we have our digits. 1, 2, 3. We're going to count. We're going to multiply it. We do 6 times 1 is equal to 6. 6 is a single digit, so I need to do 0, 6. 0, 6. And then we do 1 times 3 is equal to 3. Again, I have to make it a double digit. I do 0, 3. Add the 0, add the 3. 1, 2, 3. So my final answer is 63. 63. Thank you, NC. Hey, welcome back, NC. Hello, Zombie. Thank you so much for the follow. So let's do it again. 1, 2, 3. 1, 2, 3. Me, did that make sense? I'm trying to find a pen. Where is my pen? I had it. Oh, here it is. Here it is. Here it is. Okay. I'm starting to get it a little bit. Okay, good. So we're going to count it again. Me, when I count, how many digits am I going to put my answer? I'm going to put my answer 1, 2, 3. I'm going to put my answer in the hundreds place. So we have hundreds. 1, 2, 3. Where's the third digit go? The third digit goes because it's a single digit. When it's a single digit, it's a 0, 0, 6. That is why. So in the abacus world, when it's a single digit, we have to remember, thank you, Zombie. We have to remember, if I do 1, it will equal to 0, 1. If I do 2, it will go 0, 2. If I do 3, it's going to be 0, 3. If I do 4, it will be 0, 4. If I do 5, it is 0, 5. If I do 6, it is 0, 6. If I do 7, it is 0, 7. 8 is 0, 8. And then 9 is equal to 0, 9. When it's a single digit. Why? Because if you notice right here, we don't track our single digit. We don't track our zeros. But when we make it a double digit, that's what we do. Now, why are we going to do that? No. Hold on, Turkin. When we do that, the reason why is because when we talk about time, right? When we talk about time, we say 1:01, right? Or we do 2:04, right? So what we're doing is we're making our numbers in the minutes double digit. So when we do 60, right? 1, 2, 3. 6 times 1 is 6. 6 is a single digit. I go back one column like that. 0, 6. 0, 6. And then you stay here. We want to do 1 times 3. 1 times 3 is a single digit. So it's a 0, 3. That's what I did. Turkin, did that make sense? Yes, this is a 0, this is a 6 and a 3. Because why? This is my ones place. The ones place is my label. This dot is my ones place. When we look, we have our ones, tens, hundreds, thousands, and 10,000s. That's why. It is not 603. Okay. Oh, I don't think I did. I did 603. When I talk about it, I talk about it individual numbers. I did 06 and then 03. But when we're looking, we kind of staircase it, just like how you do in regular multiplication, right? In regular multiplication, what do? You do 60. I can't do it that one. I got to do another one. I have to do another one. Okay, sorry. I see 6. Okay, wait, hold on. Beyond that. Okay. So I just joined you in the abacus places. Okay. It's like when you write it down on paper, we use the 0 next to the row. Yes, exactly. My bad. Thanks, can you ignore me? Okay. Multiplication. Too much for my bad. No. Do you know your multiplication fact? That's a question. Do you know your multiplication fact? Because if you don't, then it's going to be a problem. If you don't know your multiplication fact, it will be a problem. You need to know your multiplication fact. That for sure you need to know. So the first thing we're going to do, we do 1, 2, 3. Oh, this would be good. So let's try to do a side. Let me try to do a side by side. Let me see if I can do a side by side. Let's see. Okay. So what are we doing? We're doing 1, 2, 3. So in Abacus world, we know we're going to have 3 digits, so we're going to be the hundreds column, right? So we do 4 times 9. We're doing distributive property. 4 times 9 is equal to what? 4 times 9 is equal to, so it would be like doing this, 98, right? Times that by 4, 36. Thank you, me. Thank you, Peach. So we do 36, right? Notice my finger moves. I go from here to here. What did we do in mainstream? Mainstream, we do this first. Oh, no. Mainstream, we don't do this first. But if I show you the mainstream, what do? We do 360. Do you see that? 360. That's what we're doing. And then when I do 4 times 8, 4 times 8. 4 times 8 is 32. Add the 3, 1, 2, 3. Add the 2, 1, 2. So what did I do here? Thank you, Peach. What did I do here? I did 8 times 4. So I do 32. So then you add it together, right? 3, 9, 2. That's what I did. What are the columns? I think I can follow after that. I never understood this type of math, honestly. There's the columns. Does that make sense, Ashley? So when we're looking, there's a dot right here. This dot is my ones place. My ones, tens, hundreds. So when we're looking, this is 2, 1, 2, 3, 4, 5. All the top beat is a value of 5. And then we have 6, 7, 8, 9, and then 10. After 10 is 11, 12, 13, 14, 15, 16, 17, 18, 19, and then 20. Me? Did that make sense? Thank you, Sarah. Thank you, Kay. Thank you, Turkin. Right? It makes sense what I just did? So mainstream does it this way. I see the dot now. Yes. I love so much in just 10. Oh, yes, good. Yeah, you're welcome, Ashley. Good sub. Yeah, so that's the difference. We could do it again. Mainstream, right? We could do it again the mainstream way. The mainstream way is what? You start from the ones. So it's, we'll do it again, right? We do 98 and then 4. When we do it again, we do this first, we do 32. You could do that. We do 32. That's all we're doing, right? We do this. And then what are we going to do? Well, we know we got to add this 0 because now we're doing 90 times 4. That's what we're doing. We're doing 90 times 4. That's why we add the 0 here. Because if you really look at it, it's actually going to be 3,600. So it's 3,600. Thank you, Anton. Yeah. So we do 36. And then again, right? So that's the difference between mainstream math and abacus math. Because abacus math, we know we're going to be at the hundreds. In mainstream math, you don't know what the number is going to be. Right? You don't know what the number is going to be. It's 360. Add 32. Because we have to add the 8 and we have to times the 8 and times the 9. So my 392. So the difference between mainstream math and the abacus math, it's not 3,600. No, it's 360. Thank you. I spoke wrong, Justin. Thank you. Okay, how do we know what we're doing to be in the hundreds? Oh, all you got to do in the abacus world, look at your number. That's all you got to do. You actually, who needs a calculator? Can you find? Oh, here. Niger. Yeah, not a problem. So, yeah. So Luna Rix, when we're looking, we look at the number. We look at our question. we can see that there's 3 digits, 1, 2, 3. So no matter what, it's going to be 3 digits. But even if it's a single digit, there's a, oh, thank you, I am bored for the bubble gum. So even if it is a single digit, you push over, so there's a concept on that. And that's why you need to know, how to make your single digit double digit. When you know how to make your single digit to your double digit, then it's easy to understand. So we have 396. That's what it is. So we have 92, right? 392. That's what it is. So I'm going to color it in. Does that make sense? So we're going to do it again. We'll do it again. You know your multiplication facts, right? As long as you know your multiplication fact, I'm just showing you the concept. Thank you for the stream. Yeah, not a problem, me. As long as you know your multiplication fact and you just do it again. Look at it, right? 1, 2, 3. 1, 2, 3. So I know I'm going to be somewhere in the hundreds. That's it. 1, 2, 3. Easy. See, that's the thing, right? In Abacus world, we actually critically think of what our question is. Thank you, Peach, for the rose. Right? I love multiplication. Right? So you critically think. We don't need to blindly just do it. We need to understand. We're going to have about 300. What are we doing? We're guesstimating, right? We're guesstimating our answer. We have 3. 1, 2, 3. We don't need to start from the ones place. We can start from the hundreds. Thank you, Lunarix. Does that make sense? Good. But that's what I'm saying. Like, obviously we could do this in our head, right? But I'm trying to show you the concept of how we do it on the Abacus. Because once you know how to do it like this, then it's scalable. Then it doesn't matter what the number is because you can do everything. But I need to show you the concepts, and the concepts are very simple. The concepts are very easy to understand. Once you understand the concepts, then you can scale it. But the biggest thing is understanding concepts. So I understand that this is super easy. It is super easy. But I'm just showing you concepts. So now we know 7 times 9. 7 times 9, you can divide. Yes, you can. If you can multiply, you can divide. Just like if you can add, you can subtract. It's a different process. It's kind of the same process, but kind of different. We can get to it in a little bit. So my final, I like it when you model. We have 63. 63. There we go. Because what do we do? In mainstream, we did 90, right? So 92, 7, right? Oh, that was the other thing. In mainstream, they're starting to do distributive property. They're starting to be like this. So they're going to say 90 times 7 is equal to 630. And then you got to do 7 times 2. 7 times 2 is equal to 14. And then you got to add it together, which we already do on the Abacus. Because if you look, we have 63, and then we do 7 times 2. 7 times 2 is 14. 7 times 2 is 14. Add the 1, add the 4. 1, 2, 3, 4. So my final answer is 644. Why do you use the hundreds column though? Because my question is 3 digits. Can you please kindly show us one way on the Abacus and then mainstream? Hopping around confuses me. Okay, yeah. So we'll do it again. I do the hundreds because my question is 3 digits. 1, 2, 3. 1, 2, 3. That's it. How do you do the split screen like that? It is on my desktop. Thank you for the follow. It's on my desktop. Thank you, Nicole. So I have 2 cameras. I have my webcam, and then I have my desk camera. My document camera. That's how I do it. And I'm on my computer. Because I don't like my phone. Because my eyes are old. So I can see the comments on my computer. But I don't see the comments on my phone because my eyes are old. Thank you so much for the rose. Thank you for checking in. Okay, so 3, Me. Does that make sense? This is why I'm using the hundreds, because I have 3 digits. 1, 2, 3. I'm just counting. I'm critically thinking that I have 4 digits. So we do 6 times 9, 7 times 9. 7 times 9. Hello, Chen. I am well. How are you? I'm very excited right now, actually. and the trolls are not too bad right now. 63. We actually did 630. See, 630. If I look at my place values, I have my ones, my tens, my hundreds. This is 630. But all I did was 63, because in our multiplication table, we do 7 times 9. We don't do 90 times 7. That's just like crazy. Okay, you saw it first. And that's because it's 3 numbers. Yes, that's right. That is because it's 3 numbers. That's all it is. I'm utilizing the understanding of what my question is. And my question is 3 digits. Exactly. Right? Simple. Simple, simple, simple. It's different. Don't think that don't think that you're being stupid. You're not. This is just unfamiliar. This is a different way of thinking. This is all just unfamiliar. What we're doing is something different. So it's unfamiliar for everybody. Okay? Just saying. This is just different. So now my next one is 7 times 2. 7 times 2 is 14. All I got to do is add the 1, right? All I got to do is add 1, right? Because it's a 4. Add the 1, add the 4. So my final answer is 644. Thank you for the follow, Danica. Thank you for the follow, Plushie. Too easy. I know. That's what I'm saying. So easy. So easy. I don't know why mainstream math makes it so complicated. But see, the difference is, you know what the difference is? The difference is that they have to write it out on a piece of paper. Whereas in the Abacus, we utilize the tool for what it is. We utilize the tool for what it is. It tracks our numbers. It tracks our hundreds, it tracks our tens, and it tracks our ones. Yes, I'm very excited about this. And I love the questions, and it's great that even if you don't understand, it gives me a different way to explain what I'm trying to say. You know what I mean? So thank you, me, for following. How do you even use an abacus? Hello! Mammy. Mammy? I love Mammy. It really does. I know, right, NC? This meth is starting. I know, Ivan! I'm telling you. But then I get the trolls. And I get the trolls as like, you could just do it in your head. Yes, you could do this in your head. This is very simple math. This is very simple. You can do it in your head, but I'm not teaching you how to do it in your head. I'm teaching you the concept, how to do it on the abacus. And then when you understand it, then you can scale it. The abacus is tricky. I can't do it in my head. I can't do it in my head either. But there was this one person who was just like, oh, just do it in your head. Just do it in your head. I was like, ugh. You know what? Get out of my stream. This is reminding me of school. Starts in a half a week. I like school. School is fun. Okay, Braxton. So, Mammy. When we're looking, I go back on the, oh. Woo! My kids start in 2 weeks, I think. Let's do a little review. Thank you for the follow, Panda Peace. 1, 2, 3, 4. Anytime the beads are touching this reckoning bar, it is being counted. All these beads, 1, 2, 3, 4, these are all singing Kumbaya. They're all holding hands and they're singing Kumbaya. Those are being counted. Anytime the beads are not touching the reckoning bar, they are not counted. So these columns are not counted. And then when we want to do 5, we do that. The top bead will always be a value of 5 no matter what. The value of 5 is the top bead no matter what. If I do this, this is not 10, this is 55. So the top bead is always 5. If I do this, this is 500. It's very helpful to have the abacus to work with during life. Yes, thank you, Miracles. This is way easier to learn than any teacher ever taught me. Oh, good. Oh, good. I'm so happy. I'm so happy, me. I'm excited for division. We're going to be very close to doing division. Let me just continue on with the review, and then we will continue on. So we have 5, and then plus 1. 5 plus 1 is 6. 5 plus 2, right? If I have 2 and I add the 5, we have 7. The last 2, yes, Nicole, yes, the last 2 are the decimals. The last 2 are the decimals because, Destin, there is a label right here. This label is my ones label. So when I bring it down, that's my ones label. So this is 2. We add the 5. We have 7. 5, 6, 7. We have 3. 1, 2, 3. We add the 5. It is 8. We have 4. 1, 2, 3, 4. We add the 5. It is 9. Well, what's 10? Easy. 10 is just a 1 and a 0. Just like how we write 1 and 0. 1 and 1 is 11. 1 and 2. Why 500? 500. This is 5,000. Because this is 0, 0, 0, 5. Did I get that? Wanting to learn. Thank you. Hello, Nora. Okay, Nicole, did that make sense? The last 2 is the decimals. So 5,000 is here. Because if you look, there's another label. That label is my thousands. And every grouping, right, is a period. I just learned that too. So this is a group. This is a period. We have our ones, tens, hundred, thousands, and then we have 10,000s. Oh, so the little wooden pieces are zeros. The wooden pieces are zeros. I learned something today. Thanks for bunch. Yeah, not a problem. Thank you for the thank you. Thank you. Quit. If you don't like the yelling, you can leave. So the little wooden pieces are zeros. Yes. So if I did this, this is all zeros. Because none of the beads are touching the reckoning bar. Okay, good. As long as you're not a troll. Could you do 5 million? Not in this one. There's not enough beads. There's not enough columns. It only goes to 10,000. Ones, tens, hundred, thousands, 10,000s. But you know what? You know what, Rylan? Because size matters, I can do 5 million. If I did 5 million, because size matters, right? We can do millions. There we go. Ones, tens, hundreds, thousands. 10,000, 100,000, millions. That's what happens. So if you look, every column has each grouping, right, has a period. Each period has an indicator. So my ones, my thousands, my millions. That's what it is. My ones, my thousands, and my millions. Why do millions when you... Exactly, right? So if I want to do billions, then I go here. So I have billions. I have my ones, my thousands, my millions, and then I have my billions. Why didn't I get taught in this? I feel cheated now. Can you pin your new adult book? I didn't bring it into my shop yet. I'm still waiting for it. Hello, Tab. Do you do 2/10? Can you do billion, cajillion, fulfillion? Because size matters, the biggest one I have is only 23 columns. That's all I got. But I ain't gonna get a bigger abacus because I think after that it's gonna be too much. So we have our ones, thousands, millions, billions, trillions, quadrillions, quintillions. But no, I do not sell the 23 column cell. This is my own. I know another person has a 27 column abacus. I think it's a little bit overkill. Only because when the numbers get really big, are you really going to use all of that? You know what I mean? Quintillion. Dunking on the trolls now. The trolls keeps me on my toes. As long as they're okay with like banter, right? Like I'm okay with banter, but don't be rude. Don't be rude. Okay. I can solve it. Can you? Let me see. Blue blah 09. Is this really what you want to see? But you don't know how to do the formulas. There's formulas that are involved. Thank you, Panda, for the rose. How about okay. They're annoying. It's great when you block them. Can you please show how to solve multiplication? I don't understand. Oh, hey, Des. Okay. So let's go back. 644. Okay, so here, let's do this. Welcome back, Des. Have you been around for a bit? All right, let's do this. So we're back to here. Okay. Yeah. Okay. Good. Calculations. How to use it. Yep. Never seen this before. Well, if you've never seen it before, multiplication is too far ahead, right? You do answers 4 digits, right? Yeah, it would be 4 digits. Multiplication means is good. Oh, thank you so much, Miracles. Okay, I've been here for a few minutes. Just followed you. Okay. I believe it would be me. Okay. So, for those of you that are just came on board, we're going to do multiplication. So, what we need to do is understand this is a 3-digit answer. How do I know? Because I look at my question and I could see it. Does that make sense? I could see my question is going to be 3 digits. I know my answer is going to be 3 digits. So why don't we utilize the information we have? We don't just blindly do multiplication. So we understand it's going to be 3 digits, right? 1, 2, 3. 1, 2, 3. Notice that my ones place is over here. I call this the 1. This is the second column. This is the third column. So we're going to be in the hundreds column. Because we're going to be in the hundreds column, what we're going to do is we're going to do distributive property. Distributive property is what? Breaking the numbers into smaller parts. So what Abacus does is it makes it into manageable chunks. And what we're going to do is we're going to do 1, 2, 3. We do 8 times 5. 8 times 5 is equal to 40. There's a 4 and a 0. I think I just visualized the Abacus using these. Good, me. We do 4 and 0. Don't forget the 0. The 0 is a placeholder. You need to move your finger to add the 0. My next one is going to be 8 times 4. 8 times 4 is 32. So add the 3, add the 2. So add the 3, 1, 2, 3, and then I go here to add the 2, 1, 2. So my final answer is what? What is my final answer? See, the biggest thing is if you can visualize the Abacus, then you're really good on the, have a really good start. I actually don't memorize my Abacus. I choose not to. But, thank you me. Yes, it is 432. Well done. Yes, 432. 400. 1, 2, 3, 4. 30. 1, 2, 3. 2. 1, 2. 322 looks like this. 300, 1, 2, 3, 22. 2 and then 2. I got this one quick. Oh, good, 300. What if it was 7 times 9 and it was 37 and you only have 4 little things? Oh my gosh, wait, hold on. I think I used the method in 5th grade multiplying. Yes. So if you had to do that, then you would have to add. So that's the thing. What are we doing? So if we had the 4 here, this is where the formula would come in. You would have to add the 6, add the 3. Add the 6 is plus the 10 minus the 4, add the 3, plus the 5 minus the 2. But again, that's formulas that we kind of bypassed. Thank you for teaching me something new. Oh, you're welcome. The blue is not 1. The blue is a value of 5. So this would be 5, 5, 5, 5, 5, 5, 5. Okay, I understand. So basically, it's necessary to multiply something with 2. Yes, exactly. It's got to be 2 digits or more. Because if you don't do 2 digits or more, then you got to do repetitive addition. Formulas are very important in order to regroup. Yes. So the formulas we're talking about is how to make a 5 and how to make a 10. Those are the formulas you need to memorize. Those are the formulas you need to understand the concepts of. When you understand these concepts, then adding bigger numbers will come into play. Yes, thank you. Just want to be myself. Yes, 432. Yes, that's what it is. Thank you, blue blah, for the follow. Right? I know this is simple, but the reason why it's simple is because I didn't want to introduce how to add the formulas yet. Because when we start introducing these formulas, that's a whole new concept that needs to happen. And so usually usually I start off with adding, subtracting, and knowing how to do the adding of the 10 and adding of the 5, making the 5 and making the 10, and then we can go into multiplication. So for those of you that just joined, you guys are late because I've been on for about almost 2 hours. So again, we're going to do some multiplication. We're going to figure out how many digits. Thank you, Dre. But usually I talk about the concepts as opposed to the answer. We want to focus on the process and not the answer. So what we're going to do is understand 1, 2, 3. 1, 2, 3. Hello, Bobby. So we have 3 digits on the abacus. We know, I'm learning a lot. Oh, good, me. Oh, good. I appreciate that. So we know that's going to be 3 digits. Again, what we're going to do is we're going to focus. I am well, Bobby. I'm well. The trolls are not too trolly. I kind of wish I wasn't late. Yes. We'll see if we can catch you up. Let's see if we can catch you up. But if you have questions, let me know. So we see our question 1, 2, 3. So we know we're going to be in the hundreds column. We're going to multiply distributive property 9 times 7. 9 times 7 is 63. Add the 6, add the 3. 1, 2, 3. Notice I don't need to say 9 times 70. The reason why is because the abacus already tracks my numbers. And we always just do 2 columns at a time, which is crazy. Abacus makes it into manageable chunks. And then what's my next one? My next one is 9 times 6. 9 times 6 is what? 54, right? Hey, chaotic! We add the 5, we add the 4. So my final answer is 6, 8, 4. Well done. Well done, well done. Thank you, me. Yes, right? Okay. It's kind of like math and martial arts. The practice right teaching you get it right. Why did you put 1 up, down? This makes math easy. Oh, I'm sorry. Why did I put 1 up? Shoot, I went the wrong way. I don't even know what I was looking at. Oh, I started from the left. I always go from left to right. You could go from right to left. You could. However, I go from left to right. I go from left to right. So, what was the question? I don't understand. Why did I put 1 up? Oh, thank you so much. I see the Pharaoh. Thank you, chaotic. Thank you so much. U plus R. Oh, you are welcome. I almost was. I have 2. Yeah. No, thank you so much. I appreciate that. You said 6. 6. 5, 6. Plus the 5 plus the 1 is equal to 6. That's why. We do 3, 1, 2, 3. So the blue, yes, exactly. The blue bead is equal to 5, no matter what. If I have 3, 1, 2, 3, I add the 5 here, now I have 8. If I take away the 5, it is 3. If I have, my next number is what? 5, 54. Add the 5, add the 4. 1, 2, 3, 4. Can you use for double digit times double digit? Yes. Double digits times double digits. How many digits are we going to start with? If you've been following, how many digits do you? 4. Exactly. Exactly. But I need to find a simple question. Hold, please. Let me find a simple question. Thank you, Sarah. Yes, it is 4. Would it be? Yes. 684. Yes, that is correct, Chris. Yeah, we could do that. We could do that. I gotta find. Sorry, looking at... Okay, so it's still 4. 1, 2, 3, 4. It's still 4. 1, 2, 3, 4. But what we're going to do is we're going to do 1 times 1 is equal to 1. 1, again, is a 0, 1. Right? 0, 1. Again, 1 times 1 is 0, 1. Because I finished this one, I'm going to now do this one. I got to count again. 1, 2, 3. Hello, good night, Christy. Right? 3. 1, 2, 3. So I'm here now. 1 times 1 is equal to 1. 1's a single digit. I add the 1. 1 times 1 is 1. 1's a single digit. I add another 1. So my final answer is 1, 2, 1. 1, 2, 1. Is there a trick to use just the tool, no pen? Yeah. Just do it. I write it out so you guys can follow. But you don't have to write it out. But I write it out so you guys can follow. Do you always have to use the formula? You only use the formula when you need to. My workbook. Oh, yeah. I'm so excited. But my Abacus is coming tomorrow. Oh. That's funny, Darth. Yeah. So we could even do 12, right? 1, 2 times that by 1, 2. Same thing. 1, 2, 3, 4, right? 1, 2, 3, 4. 1 times 1 is 0, 1. 0, 1. Add the 1. 1 times 2, right? We did this. 1 times 2 is equal to 0, 2. 0, 2. We're done with this. Do it again. 1, 2, 3. 1, 2, 3. Again. 2, right? 2 times 1 is 2. 0, 2. Add the 2. 2 times 2 is 4. Is equal to 0, 4. 0, 4. That's what I did. So it still works. No matter how many digits you have, it still works because the single digits need to have this concept of making it a double digit. That's why it works. So my final answer is 144. But thank you. I appreciate the question. I see 144. I'm stumped how you got there. So what if it's like a 5? 5 digits? Same thing. So here, me. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. 1 times 1 is 0, 1. 0, 1. I add my 1, right? That's what I did. 1 times 2. 0, 2. I recount. I'm done with the 1. Okay, hold on, Justin. We do 3. 1, 2, 3. Does that make sense, me? 1, 2, 3. 2 times 1. 2 times 1 is 2. 2 is a single digit. Make it a double digit. 0, 2. 1, 2. 2 times 4. 0, 4. 0, 4. This makes Common Core with Mac look good. Why not use the old longhand math? You could if you want to go on paper, but Abacus, you add on it. I guess where do you know where to put each number to the answer? Because the question is 4 digits. 1, 2, 3, 4. We can critically think the number. We can critically think what our answer is. Instead of just blindly looking, instead of just blindly multiplying, critically think that our answer is going to be somewhere in the thousands column. That's why. So the next one is 15. 15 times 15. Same thing. 1, 2, 3, 4. Same thing. 1, 2, 3, 4. Crazy. Yeah. 1 times 1. 1 times 1 is 0, 1. 0, 1. 1 times 5. 1 times 5 is 0, 5. 0, 5. Okay, I'm done. No, you're not. I have one more. I got to do it again. Recount. 1, 2, 3. 1, 2, 3. 1 times 1 times 5 is 0, 5. Add 0, 5. I can't add it. I can't add 5. This is where knowing your formulas happen. What formula are we going to use? We need to use this formula, how to make a 10. This is where we carry over, right? Plus 5 is equal to plus the 10 minus 5. Plus the 10 minus the 5. Then we do 5 times 5 is 25. 25. Plus the 2 plus the 5. Wait, what? Yes. Why do you have to start in the middle of the column of the rods? I never knew how to use the abacus. Gonna get just thank you. You're welcome, Dakota. The reason why is because we skipped ahead and you didn't know the formulas. That's why. That's why. There's formulas. You need to learn how to walk before we do multiplication. You need to learn how to walk before you run. That's why we needed to do adding and subtracting before we do multiplication. That's why. I'm still confused where you put the numbers. My number is I got it up to this one. Yeah, because now we have to know our we need to know our formulas. That's why. I'm okay if we go back to the basics. Is this kind of like, no, it's not like PEMDAS. PEMDAS is just order of operation, if it will help. Gosh, you guys. Is this, no, it's 15 times 15. That was the question. Okay, let's do a review. For those of you that just came on board, thank you so much for being patient. Let's do a review. We're going to count on the abacus. We have 1, 2, 3, 4. And then we have 5. We have 6, 7, 8, 9. How do we know? 9 is in the ones column. There's a label right here. They're asking about not starting on one end. Because I have a label. Do you see that label right there? There's a dot. Right. There's a label right there. Can you see that dot? Where my finger is? That dot tells me the ones place. Is that an O? No, that's not an O. This is 9. This is 0. The result is 225. Yes, thank you, Ken. Yes, the result is 225. This is my ones place. This is my label to tell me that this is the ones place. There's another dot over here. This tells me that this is the thousands place. Right? What is 5? That's what 5 looks like. 5 plus 1 is 6. 5 plus 2, 5 plus 2 is 7. 5 plus 3, 5 plus 3 is 8. 5 plus 4, 5 plus 4, 1, 2, 3, 4 is 9. If I do this, if I take away the 3, if I take away the 5, my answer is 4. Anytime the beads are touching the reckoning bar, this is the reckoning bar, this line right here. This line right here is my reckoning bar. Anytime the beads is touching my reckoning bar, that's what's being counted. So this is 4. When I add the 5, it is now 9. If I take away the 5, this is 4. If I have 3 and I add the 5, it's 8. Thank you, Butterscotch. Okay, so now, do you think this way is better than the normal way? I do, because numbers are symbols. If you really think about it, numbers are symbols. If the numbers are symbols, right, you have to think about it. But on the abacus, there's a representation. You can see that this is 8. Whereas if you write the number 8, you have to really think about what that means. All right. So the question is why did I start with the 100? Why did I start with the thousands? I started with the thousands because this is a 4-digit question. I know if it's a 4-digit question, I'm going to be somewhere in the thousands. That's why. Okay? So, you're lost at the 1. You didn't understand that this is 1. So it's kind of, yes, it is pattern recognition. Yes, exactly. Use an abacus may be older than long. It is older than longhand math. You're right. You're absolutely right, Andrew. No, I understand that. Okay, good. Your answer is in the hundreds, though. Because I have a single digit. Because I have a single digit, I have to make sure to make my single digits a double digit. Just like how we write about time. Time is 0, is 1 and 101, right? This is a double digit. So what we are doing is we're making our single digits a double digit. Just like how we write our files, right? If you were to do, because notice there's no 0 here, but we're ignoring the leading 0. In computer land, we have a 0 in the front. The 0 is a place. Hello, smooth operator. Yeah. So the 0 happens in front, but we don't label it. But in Abacus and in computers, it's to order to push the column over. So when I did 1 plus 1, okay, 1, 2, 3, 4, because it's 4 digits, 1, 2, 3, 4, right? The question is 4 digits. But if I say 1 plus 1, 1 times 1 is 1, I am over here. I cannot be over here. I need to make it a double digit so it pushes me over to here. That's why. So that's why I add the 1 here. And then 1 times 5 is 15. Again, I'm sorry, 1 times 5 is 5. 5 is a single digit. I push it over to here because it's a 0 and a 5, so I add the 5. Good. So the device answer would be, yeah, you could say 0225, but if it's the whole device, then it'd be 00225 if you want to look at the whole thing. But we don't talk about the leading 0, so it'd still be 225. Yes, thank you, smooth operator. So if you do 99 times 99, can you assume? Yes, you can still assume it is 4 digits. We can do it, but it's going to be multiplication and formulas. So if we did it, it's still 99 times 99. 1, 2, 3, 4, right? 1, 2, 3, 4. 9 times 9. 9 times 9 is 81. 81, because it's already a double digit, right? 81. 9 times 9, 81. 81. We got to do it again. 1, 2, 3. I'm sorry, I'm done with that. 1, 2, 3. 1, 2, 3. 9 times 9 is 81. Plus the 8. Plus the 8. How do I add the 8? 8 is equal to plus the 10 minus 2. Plus the 10 minus the 2. Add the 1. Then we do it again. 9 times 9 is 81. Add the 8. Add the 1. Add the 8. Plus the 10 minus the 2 plus the 1. So my final answer is 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. 9801. How'd you get 8, 8? No. No, no, no. It's not 8, 8. I got the simple one. And it gets scary. It only got scary because we didn't talk about how to do the formulas. That's all. That's all. I didn't count wrong. One, two, three, four. 81. 81. 1, 2, 3. 8. Add the 8, add the 1. Add the 8 plus the 10 minus the 2. Add the 1. 81. 81 plus the 10 minus the 2 plus the 1. Hello, Naya. Welcome back. Okay, it's confusing. That's actually not bad. Thank you. I think I am converting people. Oh my God, I've got 350 people in my room. Sorry, missed the... Yes, not a problem. Not a problem. Because... yeah, it is what? It is... there was one time I was doing freestyle math and somebody was like, that's the wrong answer. I'm like, no, it's not. And they were like, oh, ChatGPT was a typo. Because this is awesome. But we just missed, but we just missed a whole bunch of like concepts. How to plus the 10 and plus the 5. What is this? This is an abacus. An abacus is a counting tool. Thank you, Carolina. Right? This is accounting. That's all it is. It's just a counting tool. It just helps you see. But you do these things in your head. You don't have to write it out. But I do to tell you what I'm doing. You know what I mean? I don't have to do this. But I tell you. I've watched you stream the basic count. It makes so much sense. Yes. But see, that's what I'm saying. You know the concepts, right? You understand the concepts, and then you can scale it. Poetic. Thank you. Thank you. Oh, yeah. Thank you. Thank you. Thank you.
Oh, I love it. Great stuff.
Oh, here's a new one. Thank you, everybody, for leveling up. Oh, did it work? No?
Level up, 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 level up.
I actually never knew that song existed. I was watching something on TikTok and they were dancing. They were doing choreography. And I'm like, that's a great song. So I took that. All right, sorry. 47. Is there a way to multiply the abacus without memorizing multiplication table? No, you got to memorize your multiplication table. You have to memorize your multiplication table. That is just hands down. But you can do it. I mean, you could do it. It is possible you can do it. It's just one of those things. You should see the video. It's fire. Yeah, I did see the video. I had to. Times that by 4. Yeah, it's an old one. What software are you using to get both screens on my live? I am using TikTok Studio. TikTok Live Studio. That's what I'm using. I love it. I love it. But it's still limited, right? Because everybody still does their lives on their phone, and my eyes are old, so I would rather see all my comments. Am I a tutor? Yes, I am. I do tutor. I actually have a student tomorrow. I do tutor Abacus. All I do is tutor Abacus. That's all I do. I teach you how to use the Abacus. And then you go to school to learn everything else. All right. I'm going to 11th grade. Something I should know. Oh, I don't know. Notification. Wait. We use 4 to... Yes, exactly. Cure for old eyes. Young Len. And your books. Yeah, I do write a lot of books. This is the best way to... What is the best way to memorize the tables for your personal... Honestly, it would be doing the... it would be doing repetitive addition. In my honest opinion, it would be repetitive addition. Because, one, it's a pain in its cheeks, right? But because you got to go through the motion... you start to see the pattern. So if we do 3 times 1, add 3. 3 times 2, Add 3 again. Plus the 5 minus the 2. 3 times 3. Can I do it? Yes. Add the 3. 3 times 4. I can't do it. I need to what? To add the 3, it's plus the 10 minus the 7. So it's 12. 3 times 5. Right? Add the 3. Plus the 5 minus the 2. 3 times 6. Plus the 3. 1, 2, 3. Put 3 times 7. Plus the 3. Plus the 10 minus the 7. Add the 3. There I go. So I know that 8, right? 8 times 3 is 24. And then I do this one. 8 times 9. 9 times 3. Add another 3. Plus the 5 minus the 2. So my final answer is 27. You can do division. Yes, I'm going to 6. 0 times is the easiest. Very good, division. I'm so confused. What if it's 9 times 9? It's still 3 digits. It's still 3 digits. 1, 2, 3. 9 times 9 is 81. 9 times 9 is 81. So the answer is 89-1. 891. Can you recap about? All right, I'll remain hopeful. Yeah, take it slow. Don't take it slow. And as you go through, you'll get to it. You'll get to it. But just take it slow. There, yeah, like yesterday, I think it was just a little bit too much, and I think you got to break it down a little bit. Recap of the okay. Yes, thank you. Recap of the basics. Best is to and follow along with her. All right, so we're gonna count 1, 2, 3, 4. Thank you, me, for the reminder. So 1, 2, 3, 4. The lower beads has a value of 1. When they're touching the reckoning bar, this is the reckoning bar. When you touch the reckoning bar, 1, 2, 3, 4. These are counted. None of these are counted. Thank you, notification for the rows. So these ones are not counted. Okay, these are not counted. They're not touching the reckoning bar. So then we do 5. 5 will always be the top bead. The 5 is always the top bead, no matter what. If I do 5 here, this is 5. This is 50, 5 and a 0. This is 500, 500, and then this is 5,000, 5,000, 5,000. And then this is 50,000, 50, 50,000. Why? Because I have this label. That's the label. The label is my ones place. So when I look at it, I have my ones place. I have my ones, my tens, my hundreds, my thousands, and my 10,000s. That makes my following so I can learn it. Yes, that's awesome. You are bringing inspiration back to math. Get people into 3D printing. Yes, get into some 3. Yeah, you know what? You actually don't need a 3D printer. There's this one person, I don't know if he's here, but there's this one person that actually made an abacus. I actually reposted he actually made like 3 or 4 different sizes of the abacus, and he gave it to somebody, and I was like, that's really cool. He made it out of wood, which is really cool. But yeah, you could 3D print it. I'm not sure how you would do this though, because it's a movable. You'd have to separate the pieces because it's a movable thing, right? You have your rods and then you have your movable thing. And then you have to make sure that there's a reckoning bar, and the reckoning bar separates from the top beads from the bottom beads. And the bottom beads is earth beads, if you want to be poetic, and the top beads is heaven beads. Yeah. Okay. So why would anyone want this? To be really strong with their foundation of math, arithmetic, adding, subtracting, multiplication, division. It also kind of deters Alzheimer's or dementia, right? And so the other question would be, if you did Sudoku, crossword puzzles, jigsaw puzzles, chess, if you did any of that, then you would find Abacus interesting. That's why. And there's some people that don't like puzzles, and it's fine if El Kukui doesn't like puzzles. Then this is not the life for you. Woodwork class didn't make them, but your friend was ahead of the time. Yeah. It's exactly good mental exercise. And exactly, right? Like if we go to the gym to build our muscles, why don't we do abacus to build our brain? Because isn't our brain a muscle as well? That's a thing. Okay. I love chess, right? Okay. Can I play games with it? You could. You could. There is a few people that use it as a counter, and that's exactly what it is. It's just a counter, right? You could use it to track your points. So every person has an abacus to track their points. You could do it. You could do it. Like card games or board games or whatever you need to track your numbers, you could do it. So like if you were playing Quirkle, you could use this, right? Because every person would need an abacus because you would track your points. Okay. Are we doing this? Okay, well, let's do this. Let's see how many formulas is in this one. All right. Again, is there a song to remember the places? I don't know. I don't know what kind of song. There might be. Mainstream math, I'm sure, would have a song for places. Ones, tens, hundred, thousands, 10,000s. Because this is exactly what the mainstream math is. Mainstream math is just the decimal system. Abacus is the decimal system. So if you don't know your placement values in the decimal system, then you could find a song on the other one, right? To find a song for your placement values. But it works exactly the same as in mainstream math. This is just a representation of numbers. That's all it is. So if I count 1, 2, 3, 4, this is 4. This is 4 in the ones column. This is 40. This is 400. This is 4,000. This is 40,000. Because I have this as my ones place. Because this is my ones place, then I know that this is my ones. So I go my ones here. That's all it is. Sorry. Can you look up? I'm looking up. There's probably a song in the... Oh, yeah, you'd have to... Yeah. I just laugh at I will not be staying, but I'll comment the boosting action. Okay, thank you. Thank you so much. I appreciate your contributing. All right. Yeah. Right? You just have to look it up. I'm sure... I don't know if there's one for the abacus, but... We're not... people in the abacus world are not that creative. I barely got one song. One song was... what is it? The left brain is connected to your right hand, and your right hand's connected to your abacus, and your abacus is connected to your... Oh, I forget. Yeah, I put a post on that one. But there's not very many creativity in the abacus world. That's what I've seen. I don't know who else is teaching abacus, but I don't think they're as creative. Thank you, Queen, for the rose. Yeah. Yeah, that's it. That's as far as I got. Oh, I got the other one. We will do abacus. I don't know if that's a good one. All right. So again, we're doing 4, 1, 2, 3, 4, and I don't know how many formulas there are, but just so you know, if there are formulas, I will write it out. And if you get confused, we have to go back. I apologize for being off topic. Are you streaming from a computer and using your phone? No, I'm using my computer and a document camera, and you can see my junk on my table. Top 40 jam. 1, 2, 3, 4. So we do 4 times 4 is 16. I'm sorry. 4 times 4 is 16. Add the 1, add the 6. We're over there. You're welcome, Tony. 4 times 7. 4 times 7 is 28. 28. Add the 2. 1, 2. Add the 8. 5, 6, 7, 8. So we're done with our 4. We're going to do it again. 1, 2, 3. 1, 2, 3. So 7, this is where we have to do the formulas, right? Because why? We don't have enough. 7 times 4 is 28. Add the 2, add the 8, add the 2. To add the 2, we need to plus the 10 minus the 8. Plus the 10 minus the 8. And then we add the 8. Add the 8 is equal to plus the 10 minus the 2. Plus the 10 minus the 2. 7 times 7 is 49. Add the 10, add the 4, add the 9. Add the 4, can't do it. Thank you, Poetic. Yes, add the 4. How do we do it? Plus the 4 is equal to plus the 9 minus 6. Plus the 9 minus the 6, add the 9. So there was a few things that we had to know before we did multiplication. So my final answer is 2209. Yeah. Oh my God, I connected to that. I actually, yeah. Because you got to get ready for the formulas right here. The formulas is the adding of the, is making sure we understand how to make a 10. When we understand how to make a 10, then the formulas will make sense when we add when we do multiplication on the abacus, right? Because what do we do? I mean, even with mainstream, let's do mainstream. So even on mainstream, it works exactly the same. I could show you the way we do it on the mainstream, right? But you start from the ones. So this is a 9, this is a 4. So what? 28 plus 4 is 32. We're done here. We got to do 40. So now we do 7 times 40, right? That's what we have to do. That's why you bring down this 4. So it's 8, and then you add the 2. 8 times is 16 plus 8 is 18, right? Do you see how we had to add it? So then you have to add it together. 9, 10, 2, 2. But now, okay, but so then how did I do it Abacus way? Abacus way, we did it the other way. We did it left first. We did this first. So we do 4. 1, 2, 3, 4. What do? We do 4 times 4 first is 16. Add the 1, add the 6. Add the 1, add the 6. And then what do? We had 28. Add the 2, add the 8. Add the 2, add the 8. Okay, we're done with the 4. We do it again. But now we go 1, 2, 3. Why? Because we do this way first. So what happens? We go here. 2, 8. Add the 2 is what? Plus the 10 minus the 8. And then add the 8. Plus the 10 minus the 2. So now what do? Then we do 49. 49 is this way. Add the 4, add the 9, add the 4. Plus the 4 is equal to plus the 10 minus 6. Plus the 10, take away the 6, plus the 9. That is what we did. So in Abacus world, that's what we're doing. In mainstream, you kind of clump it all together. But in Abacus world, we do one step at a time, and we break it up into smaller parts. 94. Right? So what I did was I did my multiplication one at a time, my distributive property, and I sectioned off every column, and then I added it as I went through. That's what I did. So when we're looking, right, it's exactly the same, right, as doing this. But it's different because it's on paper. When you're on paper, there's no restrictions. But on the abacus, there's a restriction. So you do it one step at a time. You don't need to combine steps. You're combining steps here. This is going to be the live over 5,000. This is going to live another 5,000 years. The new math won't. Yes, exactly. Haha, username. Hello, fellow abacus enjoyers. Well, you could ask ChatGPT, but it's wrong. I've asked ChatGPT many times, and if it ever comes correct, then you know it comes from me. Because I've been feeding Chat my stuff. So if you see anything that's abacus related, try it out, Caesar. Try it out. Let me know. But I tell you right now, it doesn't do abacus. It does mainstream math. Even division is a debacle. Chat only curates the information that's out there. So what I'm telling you right now is not out there. Chat's garbage. The only only reason why chat works for me is to take my stuff and reiterate it. That's all it does for me. I can only give it my stuff, and then it will know what to do with it. But if you look for chat, like for you guys, and you want to do Abacus on chat, you can't do it. Because if you say I want simple, I've been hooked since Friday night. you yeah. Thank you, smooth operator. I was wondering if the Abacus is a reason they call them bean counters. The reason why is they actually use beans. At the time, they used beans, pebbles, and but yeah, that's what it was. Is back in the day they used pebbles. Bean counter. I'm not sure why they call them bean counters. Yeah. Maybe they used beads at a long time ago, or maybe I don't know. I don't know. Austin. Each color? No, nothing. The colors mean nothing. It's just to be pretty. It's just to be pretty. So when we're counting, thank you, Austin, for the reminder. We have 1, 2, 3, 4, 5. The top beat is a value of 5. We have 6, 7, 8, 9, and then 10. Does that make sense, Austin? I appreciate the way you offer this as a way to possibly avoid dementia. Yeah, you're welcome. And it was funny. Like, I didn't think about it until, like, going down this path to show everybody. And I realized that it really, and it's kind of cool because it still can pertain to life. Like, if you wanted to make sure you knew you got the best deal on products, right? Like, you can do division. You can do it on the Abacus. Right? And you can start thinking about like other ways how you do math. Like Sudoku is not really pertaining to daily life. But like if I wanted to look at, you know what I mean? It's just interesting. I don't know how to add on the Abacus. I don't know how to add on the Abacus. Ooh, okay, I understand. This is a great way to let the kids understand mathematics. Yes, it is. It's very visual. So when we're looking, we have 11, 12, 13, 14, and then 15. That's all it is. So what we're doing is we're representing the numbers. I've heard both beans and stayed in the expression. Yeah, I don't know. I don't know how to add on that, on the Abacus. I don't know. What? What are we doing? Oh. Oh, you guys are funny. Okay, so we have thousands. No, we have hundreds. So every column is a placeholder. That's what it is. So we have our ones, tens, hundred, thousands, 10,000s. I use the colorful ones because it's prettier. And if you'll notice that there's a label right here. There's a label right here. This label tells me, my label tells me the ones place. This one tells me the thousands. So I can see it. I don't need to count it again. I don't need to count ones, tens, hundred, thousands, 10,000s. What I can do is just be like, oh, this is my hundreds. This is my ones. I see that this is my thousands. So these are grouped into periods. That was a new thing I just found out. So we have ones, tens, hundreds, thousands. It'd be the same thing with this one. We have our ones, thousands, millions, billions, and trillions. And so they're grouped into periods. We have our ones, tens, hundreds, thousands, 10,000s, 100,000s, million, 10 million, 100 million, 1 billion, right? And then 10 billion, 100 billion, and then trillion. So when we're looking, every column is a period. Every column is a grouping. Okay. I wish I was taught that. Yeah. It is very interesting. It might be definitely one for my little sister where you could buy it here if you want. I don't know. It's linked in the thing. How old's your sister? Because I do have books. I do have books to go with the Abacus. I have this one. Depending on how old your sister is, I have a 2-digit maze book, and the 2-digit maze book, and these are all the books that I created. The 2-digit maze book is just 2 digits, and we do a review, and I give you an explanation on how to read it on the Abacus. So we have our ones, our single digit, and after single digits, right, then I give you a review on the double digits, and after the double digits, then there is this thing. So then, this is the maze, and then, I see what you did there. Oh, so, when we're looking, I give you this mask maze, and you try to understand what this number is. So, but no, these Abacus are not available in Walmart, but I do sell it in my TikTok shop, and there's a bundle if you're looking for it. Cool. Thank you, Alex, for the share. All right. Are we going back to basics? Do we want to do the 2-digit number? Let's do that. Let me test you guys. There's a lot of people here. Let me test you. I need to find my. Here we are. No, it's over here. I found it. All right. I'll look into it. Thank you. Yeah, not a problem. Let me know if you have any questions about my product. I do have more stuff. It also depends on how old your sister is. But I do have more stuff that goes to it. Yeah. Wow. I have a lot of people in this room. Okay, what do we number? What's our number? We have our 1s and our 10s. So if this is our 10s and this is our 1s, what number do we think that is? This number. Oh, yeah, right. What are we doing? 31. Oh! And it's not 11. It's 61. Thank you, Stoic. What? Thank you. She's 31. So, I have a 2-digit here. Either a 2-digit, I don't know how comfortable she is, but I have a 2-digit Abacus puzzle maze. I have a 3-digit and a 4-digit. They are available over here. My name is Lynette. Oh, 13. Okay, so if she's 13, then I would recommend a 4-digit Abacus maze first to be able to get comfortable with reading the Abacus, because there's a few steps you need to understand. One is how to read the Abacus. 2, then you have to understand how to do how to make a 5 and how to make a 10. And then when you understand that, then you can go into multiplication and division. 61. Thank you. So it takes us to this number. What number do we think? Good teachers bring students, or we need, yes, I need the TikTok algorithm to bring in students, because if it wasn't for TikTok, I would not be as popular. Yeah. 35. No, almost. It is not 35. It is 39. Thank you, Stoic. So we have it 1, 2, 3, 30, 1, 2, 3, and then 9. The top beat is a value of 5. So we have 5, 6, 7, 8, 9. We have to pay attention that anytime we have the top bead, this is what 35 would look like. The bottom beads is a value of 1. The top bead is a value of 5. So this would be 35. So then we have 36, 37, 38, 39. You've got a university graduate classroom watching here right now. Thank you, Rockstar. Thank you, me. Did that make sense, Chelsea? And yeah, I know I have a wide range. I have kids as young as I think 3rd or 4th grade, which is crazy. But they enjoy it too, and they're starting to understand. There's a few kids that show me to their teachers, and the teachers are like, "That's fine. You get to learn." I was like, "What? Pay attention to school." But it's funny. And I appreciate that. Yes, thank you, Stoic. Wow, well done. It is 51. Thank you, Chelsea. Thank you, Stoic. So that's what 51 looks like. Yeah, and so be careful with swearing, please, because I do have children. I do have children in the room, and I don't want to. I know they know how to swear, but I don't want to encourage that. Thank you, Stoic. It is 64. 1, 2, 3, 4. Well done. 64 takes us to this, and then we have that. We have our 10s, and then we have our 1s. What number do we think that is? 3. Thank you, Alicia. Thank you, Stoic. Yes, it is 3. Simple, right? Simple to use, easy to understand. So then our next number is, don't be scared, Easy. Because even if you get the wrong answer, we can see how we can correct it, right? If you never let me know, then I won't know. Like it's 26, can't be 26. Because 20 looks like this. This is what 20 looks like. 6 looks like this. 26, 5, 6. 28 looks like this. 20, right? 1, 2. 1, 2. That's what 20 is. 8, 5. That's 5. So this is 25. Then we do 6. That's 26. 27. 28. That's what 28 looks like. What I did was 99 because every number is represented on the column. So when we're looking, we have 9, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9. Right? That's what 99 looks like. See how it's 9 and 9? So we're doing a representation on the abacus. And this is why we go through the maze to see how to read the abacus. So when we have our our tens and our ones, what number do you think? Yes, Stoic. It is 91. Thank you, Dave. Thank you, Stoic. Well done. Does that make sense? Riku, 91. 5, 6, 7, 8, 9, and then the 1.
Oh, I can see everything.
Thank you, Riku. So our next number, we have our tens, and then we have our ones. What number do we think that is? Yes, it is not 21. It is 75. Almost 75. The 1 is this. That's what 1 looks like. So we have to pay attention. If the bottom bead is touching, that's 1. But if the top bead is touching, that's 5. So when we're looking, the 5 is at the top. And the bottom beads are a value of 1. So we have 75. Yep. Not a problem, right? It's all about understanding. And if you don't tell me the wrong answer, then I don't know how to correct it. So when we're looking, we have our tens and we have our ones. That's all we're doing. We're doing representation. It is not 14. It is 50. 14 is the 1 here. That's what the 1 looks like. This is 5. 60 looks like that. But we all got the 4, which is good. Yep. So the top bead is a value of 5. Thank you, Chelsea. We have the bottom bead is 1. It is not 64. 64 looks like that. This doesn't have a 1 attached to it, right? So when the beads are touching the reckoning bar, they're being counted. This bead is not supposed to be there. It's supposed to be like that. That's supposed to be 54. So then we have our next number. We have our tens and we have our ones. I used to know this. I get it. Oh, good, Riku. Yes, thank you, Aiden. Stoic, Dave, Riku, Chelsea. Thank you. I thought it was a typo. Right? Because it's 25. The top bead is 5. But I don't use it now. I don't imagine you using it now anyways. I mean, if you already know how to use a calculator, the idea is to get a strong foundation of arithmetic. If you know how to do it, then it's good. So if you knew how to do it when you're young, then it's good. My boys, they all know how to use the abacus, but they don't use the abacus because now they're doing calculator stuff like trigonometry, calculus, pre-calc, algebra. They don't need to use the abacus for it because abacus is only for arithmetic. Adding, subtracting, multiplying, and dividing. That's all it needs. So the answer is 58. So 13 looks like that. 1 and a 3. 1, 2, 3, 1. 58. We have 5. The top bead is a value of 5. We have 8. 5, 6, 7, 8. That's what that looks like. It's 5 and then 8. 58. And then we're here. Our next number is the answer to the universe. Thank you, me. Thank you. Khalil, Aiden, Dave. Yes, 42. What are the other columns for besides the ones and the tens? That's a very good question. Thank you, Aiden. So, Every column is a place value. So we have our ones, tens, hundred, thousands, 10,000s. Yes, it is 42. If you want to work with decimals, you just exactly. You either use this one to work with your decimals, or you do this one and you just shift everything over. So then you have more room to have decimals. Yeah. Someone read the Hitchhiker's Guide to the Universe. I'm getting this from a 4-year-old. Oh, fantastic! Since you have a 4-year-old, I would recommend this book. Is the Preschool to Abacus. The reason why is because they would need to know their numbers, and I talk about how to get their numbers. So when we do some practicing of like the tracing and then finding the numbers, and all of my books is all Abacus specific. And so I have am I a math teacher? I am. Abacus is math, Aiden. Abacus is math. And so I have activities and I try to make it engaging. And then after the second lesson is 5 to 9, because I like to break up the idea of counting from 5, 6, 7, 8, 9. So I try to make it logical, as well as getting them to understand how to read the Abacus, as well as the activities. And so this is reinforcements. And then after the reinforcements, we go through the paths and more go to the activities. This is just learning how to see the numbers. Then we start counting forward, right? After we count forward, we count backwards. After we count backwards, then we talk about what comes in between, right? What comes in between. And this is about the relationship of the numbers. This one is about, what comes after. And then this is comparing what's bigger, what's smaller. And then afterwards, we start going into adding and subtracting. So this is where I would start with everybody in the room to how do we start adding and subtracting. This is a lot about how to move the beads. And what we're doing is we're understanding how to move it. So we have 7 on the abacus, 5, 6, 7. In abacus world, what we do is we focus in on the second number. When we focus in on the second number, we need to just, can we add the 1? Can we add the 1?
Come on, do it.
Oh.
Do it.
Yeah, we can add the 1. So my final answer is 8. We're not focusing on okay, NC, I'll see you later. We're not focusing on the result. We're focusing on the process. I don't know big words. I don't know what big words I said. Thank you, Queen Glow, for the rose. So when we're looking, right, we can do it again with the 2. When we do the 2, again, we have 5, 6, 7. We know how this is 7 is. What does 2 look like? Well, we add the 2. Can we do it? Yes, we can. So we add the 2. 1, 2, right? But it doesn't matter which 2 beads, as long as it's 2 beads. So if I had 6, I want to add 2. It's these 2 beads. It's not these 2, right? It's these 2. And then if I had 5, it'd be these 2 beads, right? So 7, 5, 6, 7. I mean, do you teach like in a physical classroom at school? No, I don't. But we completely comprehend the complexity of your professity. I love it, poetic equation. All right, so then we have 5 plus 3. We have 5 and then we have 3. 5 plus 3 is 8. We can supertize. Supertizing means that you can look at the number and you know what it is. So we have 5, 6, 7, 8. Right? In mainstream, right, in public school or mainstream math, right, you can do dots. You could do dots or you could do tallies, which is perfectly fine. I would like to do it on the abacus because it's easy to see. It's because now I can scale it, because if I have the 5, if I have 50, 5, 0, I want to add the 3. 1, 2, 3. I can do 30. 50 plus 30 gives me 80. This is 80. How do I know? Because this is my 1s, this is my 10s. 5, 6, 7, 8. 0. You could do the dots. That's a whole lot of dots. That's a whole lot of dots. So that's why I would rather do the abacus, because it's scalable and we do representation. You can do 500, 500 plus 300. 1, 2, 3, 300. Gives me 800. That's a whole lot of dots. That's a whole lot of tally marks. So then we can keep going. And then if you know how to add, you will know how to subtract. We have 4 on the abacus. 1, 2, 3, 4. We can take away the 1. That's all we're doing. When you take away, you remove it away from, you move away from the reckoning bar. That's it. When you add the 1, you take away the 1. If you know how to add, you know how to take away. Because it's just the opposite motion. You add, you go to the horizontal bar. You take away, you go away from the horizontal bar. So even if we had the 2, I have 3 on the abacus. I want to take away 2. I'm taking away these 2 beads. That's all I'm doing. Take away the 2 beads. So I add the 1, I add the 3, 1, 2, 3, I take away 2. That's it. And then we can do it again with the 3. We add the 3, we add the 4. Can we take away the 3?
Yes, we can.
1, 2, 3. So my final answer is 1. Right? And that's what it is. The book is about learning how to do simple stuff if we have enough. So here's my next one. I have 3 on the abacus. 1, 2, 3. I want to add the 5. The 5 is the top beat. Can I do it?
Yes, we can.
Yes, I can. I can add the 5. So my final answer is 8. 5, 6, 7, 8. How do you do multiplication or division? We can do it, but it might be complicated because you need to know the foundations, right? You need to know how to add and subtract before you can go to multiplication. When you're in kindergarten, did they teach you multiplication? No, they taught you adding and subtracting first. So adding and subtracting on the abacus is the first thing you need to understand. And then we can go into multiplication. I could show you multiplication, but I don't want you to get scared. And I don't want you to be telling me that it's too easy. You know what I mean? But we were doing that. All right. What are we doing? But yes, we can do a multiplication and division. Let me finish my thought. Can't wait till you get a counter-intrusive fractions. Yeah. Thank you, Monica, for the follow. So, hello. So we do 1 plus 6. Plus the 6 is here. Gotta use distributive property multiplication. Yes, we do distributive property. Yes. Right? Imaginary numbers. Oh my gosh. Yeah. Anyways. 6, we add the 6. So we have 1 plus 6 gives me 7. Thank you, Darth. Have a good night. Have a good night. I will see you in my next live. So we have 8. We have 1 in the abacus. 8. Can we do it? Can we add the 8? We can add the 8. So my final answer is 9. And that's it. Right? Add the 9, take away the 9. Add the 9, take away the 9. Yep. That's it. So, thank you everybody for joining. Thank you everybody for joining. Please keep your mind open for something different.
Now open your mind to me, please. Open your mind.
It is different. It is not new because Abacus has been around way longer than new math. But yes, we can do multiplication, but I would like to introduce how to make a 5. The reason why is because we don't want to memorize our doubles. What we want to do, no way, Total Rico, oh my, you know. Thank you everybody for joining. Thank you everybody for joining. I am here to show the Matrix what an abacus is.
Welcome to the real world.
I remember being good at this in high school, but yo. All right, so what are we doing? We're going to be understanding how to do this. Thank you for the follow. Hey, Aces, welcome back. Welcome back. I was doing research on what base 10 was, and then I was doing research on like what it means. So binary is just the 2, 0 and 1, but base 5 is 0, 1, 2, 3, 4, 5, right? And then base 10 is 0 to 9. And we're at the decimal system. And then I remembered there was one person who was like, it's what did he say? It was so counterintuitive to subtract when you needed to add. And I'm like, well, what do the Romans do? Do what the Romans do. They took a 5 and then take away the 1. If you think that's funny, it taught me having this last month. Oh. Go again. Give the people air. Give the people air. Okay, yes. What are we going to do? Oh, we're doing this. What happens? Well, what are we doing is we're understanding how to add the 5. we're not going to memorize 4 plus 4. What we're going to do is we're going to understand a concept. The concept is how do we utilize a 5? That's what we're going to do. That's what we're doing. So you could count up easily, right? If I had 4, I don't know how many people have used this, but you have this, right? You can count 4. 1, 2, 3, 4. 1, 2, 3, 4. And you can bring it together and you can count it up. That's fine. That's fine. You could do it. I'm going to show you the Abacus way because Abacus is the greatest thing next to sliced bread. Now, if we had 4 in the Abacus, there's my 4, right? 1, 2, 3, 4. This is the 4 that we're looking at. I barely understood the multiplication. Division. No, division's actually, if you understood multiplication, you would understand division. But don't forget, you've just started learning, right? I've been doing this for 20 years. So don't compare yourself to me because I've been doing this for 20 years. And I know how to count really well from 0 to 9. All right, so we do 4. But notice I don't have any more loose beads to add the 4. And if I do 4 here, this is not 4. This is not adding 4 because this is 44. Now we're doing a representation. This is 44. This is 4 10s and 4 1s. What we want to do is we want to add 4 to the 1s. To add the 4 to the 1s, I'm going to have to utilize this 5. This is where the nickel comes in. This nickel is more than enough for the 4, but that's too much. I need to, what? I need to take away the 1. So if I take away the 1, my final answer is 8. 5, 6, 7, 8. I can show you on my Abacus. I can add the 5 and take away the 1. And my final answer is 8. 5, 6, 7, 8. So what did I just do is I showed you a concept of what? How do I utilize the 5? I know this concept, how to make a 5. Now I'm utilizing it. I'm restricted with the Abacus to figure out how do I add 4 to the 1's place. I could do it again, so let's practice. If I have 3 on the Abacus, I have 3 on the Abacus. I'm going to add another 4. In mainstream, you focus on the result. But in Abacus world, we focus on the second number. We focus on the number that we're trying to do. So this book is available in my shop. And what do? We add the 5. But that's too much because we're only looking at the 4. We take away the 1. So my final answer is 7. 5, 6, 7. I could show you again on the Abacus. I can add the 5, take away the 1. My final answer is 7. Let's do it again in a different way. I have 3 on the Abacus. 1, 2, 3. Right? 1, 2, 3. What am I going to do? I need to add the 4. I have this package. This package is 5 items. 1, 2, 3, 4, 5. I only use this 4 right here. So I need to take away this 5, this one cube. But it's attached to this package. But I can take it away from here. Do you see that? So now I replaced it. I balanced the equation. I replaced it with this. I could take away the 1 and I can add the 5. So my final answer is 7. 5, 6, 7. And we could do it again with the 2. So we have 2 on the Abacus, right? 2 on the Abacus. Again, if I add the 4, it's going to be somewhere around here. 1, 2, 3, 4. I need to remove this 1, but it's attached. So I need a minus from here because this is a loose bead. It's no longer attached. This is a loose bead. So I just take it away. So now when I bring it together, my final answer is 6. I could show you again on my Abacus. Add the 5 minus the 1. So that is the formula. Plus the 4 is equal to plus the 5 minus the 1. What we did is we leveled up our addition sentence. Nope.
Level up, 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 level up.
Yep. So we leveled it up, right? Now we're utilizing this 5 because we were restricted on the Abacus. It's too damn late for math, ma'am. Lalo. Then get out of my room. Because you didn't have to be in here. I did not make you to be here. But you just added to my audience. So now I'm at 329. Thank you, Lalo, for coming in and commenting, because you just added more to it. I appreciate you. Thank you so much for commenting. I love it. I love it. Nope, the beads we knew. Oh, we love to move it. That's a good one too. That's a good one. I'll have to do that one. All right. So here's another one, right? Why? Because we have a set, right? We know that there's 1 and 4 is equal to 5. We know, right? This is a set. We have another set that we need to understand. 3 plus 2 is equal to 5. Now, what we're going to do is we're going to modify this information, and we're going to utilize the 5. That's what we're going to do. So when we look, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And then we're going to add the 3. Right? To add the 3, we have this package, but guess what? We're only using the 3 cubes, 1, 2, 3. We have to remove the 2, but because this is attached, we can't move it. We got to subtract it from here, 1, 2, and we take it away like that. When you do subtraction, is the same, yeah, exactly, it is the same as the 5 minus 4 equals to 1. So we do the 1, and you take away the 4. When that happens, that's this number here, 4. 4 plus 1. So aces, when we're looking, right, 4 plus 1. Plus 1 is plus the 5, take away the 4. So my final answer is 5. Welcome to class, and you are late. I've been on for quite some time. Does that make sense, aces? So when you're looking at that, yes, it is this one. When we look for the 1, we have to minus the 5 plus the 4. So yes, and there's a whole, then that's the whole set. The whole set is plus the 4 is equal to plus the 5 minus 1, or plus the 3 is equal to plus the 5 minus 2. The next one is plus the 2. If I want to add the 2, I have to plus the 5 minus 3. Or, and the last one is, when I want to add the 1, I can plus the 5 minus the 4. Does that make sense, aces? Yeah, I should get that one too. Move it. I should get that one. Move it, move it. I have to find it. And then aces, just so you know, there's the reverse. Minus the 4 is equal to minus the 5. And that's what this is. Sublunary solutions. Whew, that's a big word. So just like here, minus 3 minus 2 equals minus 5. We would have to modify it, right? We're going to minus the 3. Isolate it. Minus 3 is equal to minus the 5 plus the 2. So what do we do? If I had 6, I want to take away the 3. Minus the 5 plus the 2. So my final answer is 3. Did that make sense, aces? So, and that is adding of the 5. And then this book itself, oh, it's the, yeah, right, it is the opposite. So when we're looking, right, this is the mazes. For people who can do math equations super fast, is this the way they learn? Yeah, if you saw the kids that do this, they learned it through the Abacus way, the Abacus method. That's what they did. Yes, Jay Hunter, you're absolutely right. My nickname 100. Wrong! That's the wrong. I don't know what that means. So this one specifically, this book specifically is about how to make a 5, right? And what I was trying to do is I was trying to solidify this concept. This concept has to be to a point where it becomes automatic. And when it becomes automatic, then it'll be easier to do the next set. So obviously, if you know how to add the 5, you will know how to subtract the 5. So in this specific book, there's a whole bunch of practice. Yeah, you're welcome, Jay. You're welcome. And so when we're looking, I have color by number, and I wanted to make it interactive. And I didn't want it to be I didn't want it to be boring. And so I felt like the mazes were kind of cool. There was the hidden word, so you figure out you figure out what your answers are, and then you figure out what the word is. There's the word problems, because I felt like the kids needed to understand how to read the word problems. And again, more color by number. There was tic-tac-toe, and then I try to make another game with a die. You make a die. This is what the die looks like. You try to make a 5 out of it, and then that's it. And then if you're ever looking, if you want to know what the answers are in the back of the book. So the answers are in the back of the book, just in case you didn't know what I was thinking, right? But I do have enough, and I think this all practices, right? This is all about practicing how to make a 5. After you make a 5, after you learn how to add the 5, the next one is to minus the 5. This is the next book, How to Minus the 5. And it's exactly what Aces said. It is the exact opposite. So, and again, we go back to, but then it becomes easier to understand the concept, right? Then we don't need to worry about how to do it, because we know, if we know how to add, we will know how to subtract. If I have 4, I want to take away 4. To take away 4, all I got to do is minus the 5 plus the 1, and my final answer is 4. But see, if I want to add the 4, this is the number pattern. We add the 4, we take away the 4. Add the 4, take away the 4. And that's it. Oh, what one is this one? It is this one over here. And I will pin it, if I can find it. That's the 10, this is the 5. So this is the minus 5. It is available in my shop, and it's the same thing, but just the opposite. And that's where we talk about the minus the 3. Right? That's where this comes in. Minus the 3. And here it is. Minus the 3. Still waiting for the add book. Yeah, it's coming. It's coming. I think it's going to be like 3 weeks out. I ordered it, but it takes time for them to print it all out. So here it is for the 7. So I have 7 on the abacus. I want to take away the 3. To take away the 3, I know I'm going to minus the 5 plus the 2. So I have to minus the 5 plus the 2. So my final answer is 4. And then here are more activities, right? This is a spin the wheel. And what it is you take a paper clip, you spin it, and wherever it lands, you put it here. Shipping. Unless you air ship them. Yeah. Yeah, that's the one thing. And yeah, so the number is 16. So I've added 16 on the abacus. I want to take away 3. I don't have any random beads. I don't have any loose beads to take away, but I have this formula. I have the directions to take away the 3. All I have to do is minus the 5 plus the 2. And my final answer is 3. Can you color in it? Yes, you can color in it. I made parts of it colorable. There is color by number. There's a mosaic. There is a secret word, and there's a word ladder. There's a word that was pretty cool. The word ladder. So I try to make it an adult version of my books. But the thing with the adult version is you get add the 5 minus the 5 plus the 10 minus the 10 and 2-digit equations, whereas the children one is one concept at a time. Why not use a calculator? How old are you, Trey? If you're like a young person, right? Then you're probably already using a calculator. But if you're in first grade, you should not be using a calculator. But if you're old, like me old, you might want to start using an abacus because you don't want to have dementia. But it's up to you if you want dementia. Completely up to you if you want dementia. You can go right ahead and not use your brain. That's fine with me. No judgment. There's no judgment. But I guess you don't like to work out Sudoku, or I guess you don't play chess, right? Or jigsaw puzzles. You definitely don't do jigsaw puzzles. What else do you not do? Puzzle games? Yeah, you definitely not do puzzle games. Surprising how the human responds to, yeah, right? It's crazy how that when you can color, yeah, I like it. No, Trey just doesn't do anything productive. Trey probably just does the doom scrolling and doesn't actively learn things. Because having that comment about a calculator, if you just sat a little bit and understand what we're trying to do, I think the comment's kind of rude. So, or maybe Trey is this huge, gigantic person that doesn't exercise because they don't exercise their brain and they don't exercise their body. Thank you, Trey, for the comment. Thank you, Trey, for the comment. I apologize if you have diabetes and you have hypertension, but that is not my fault. That's because you didn't exercise. All right. So minus the 2. When we minus the 2, we're going to do it again. So we have 6 on the abacus, right? 6 on the abacus. We want to take away the 2. Take away the 2, again, is the same concept. We minus the 5 plus the 3. Right? Because what we're doing is we're understanding how to utilize this 5. We want to take away the 5 because we have too much. So what would this look like as the thing? As the bricks. So when we're looking at the bricks, thank you, new TikToker. Yeah. So when we're looking at the bricks, right? When we're looking at the cubes, we have take away 2. Do you see how we have to take away the 2? We have it here. 1, 2. This is 2. But if we take this whole thing away, we have to add back 3. That's what we're doing. So what we're doing is we're taking away the 5, but we have to add back the 3. So we take away the 5, but we have to add back the 3. So our final answer is 4. That is why, that's what that means. We have it in here, but we have to only take the 2 away. But to do that, we need to add back the 3. That is why we have to add the 3. And then we could do it again with the 25. So we have 25 on the abacus. We have the 2 and the 5. We want to take away the 2. Remember, if it's 20 and the 5, we want to take away these 2, but it's stuck in this package. So if I take it away, I have to add back the 3. So I add back the 3, and my final answer is 23. Oh my God, that's what I'm going to do. When somebody says that we should just use a calculator, I should just tell them that they're diabetic and they're obese. Is that a problem? They're diabetic and they have hypertension because they don't take care of themselves. I'm not saying that abacus is the end all. I'm just saying that it's fun. That's all I'm saying. It's just fun. It's just fun. Right? And we do the same thing with the 5. We have the 5 on the abacus. 5 on the abacus. And then if you notice, I want to take away the 1. When I take away the 1, right, it's inside this cube. It's inside this 5 right here. But I have to add back the 4. So it's plus, take away the 5 and then add the 4. That's what I got to do. Now I respect this woman. I love trolls. They keep me on my toes. Okay, but see, that's what I'm saying. Like, what we're trying to do is I'm just showing you a concept. These are easy. I know these are easy, but understanding the concept is the first thing. Once you know how to understand the concept, then everything is scalable. So here's a question. We already talked about. Here's a bigger question. We want to have better to say those who cheat in mental are only cheating themselves. That's very poetic. But that's a lot of thinking. So here I'll show you how we could scale it. We have 1, 3, 5, 7. I can't believe Fish Guy is still here. You've been on for like 3 hours. I've been on for 3 hours. You guys are nuts. It's the middle of the night. It's like probably like really early. This is great stuff. Thank you, Hunter. Thank you, Jay. Oh yeah. So we're going to add 2. Can we add the 2? Right? We're adding the 2 in this column. We're adding 2 in this column. Can we add the 2? Yes, we can. Okay, now we have to add the 4. This is the column we add the 4. Hey, Izzy, welcome back. Oh, that's a lot to remember. Okay, so we have to add the 4. We know how to add the 4. Plus the 5, take away the 1. Now I just showed that it's scalable, right? We don't have to do, what do we have? Friendly numbers. We don't have to do friendly numbers here. We just look at our number that we're trying to add, right? And then we have the 3. Can we add the 3?
Yes, we can.
1, 2, 3. And then can we add the 1? Yes, we can add the 1. So our final answer is 3,788. I'll have to pin that. No, I wonder if I could make that. Maybe I'll make it into a sound bit. Better to, those who cheat in mental exercise are only cheating themselves. That's funny. That's funny. Okay, so that's what the answer is. 3,788. That's it. That's it. Right? So what we're trying to do is I'm trying to show you that it's scalable. Once you understand the concept, and that's the concept. Once you understand the concept, then you can scale it, and it doesn't matter. So then when we start doing multiplication and you start seeing numbers, you'll be like, "Oh, I know how to do that." So what are we doing? We're reading the abacus. Now we're doing addition. We just did subtraction. We have to do the next set. The next set is adding of the 10. That's what we're doing. Adding of the 10. Oh, so going back to this one, just so you know, again, the activities are spin the wheel with a -4, and then we have tic-tac-toe, and then this one was more like trying to understand how it can be situated differently, and then you're supposed to color it in. We have color by number, and we have spin the wheel, and we have, what else do we have? We have tic-tac-toe, and oh, this one was a cool one. This one is the petals. So what it was, these are petals. And so you find the answer, and then you're supposed to try to find the rosebud. So this is a lot about cutting and pasting as well, because I wanted the kids to practice their cutting and pasting. And so you find the answer, right? You find the answer with the abacus, and then you find the answer, you find the flower bud. I still have hidden words in this one, and then I have word problems, and then I have mazes again. I have mazes. I like mazes. And then that's what I did. So this is all about, and then towards the end is a lot about just practicing and making sure that they understand how to subtract the 5. And it's a lot about just practicing. So it becomes more familiar. And we still have color by number. Color by number. And then we have more color by number. And then more mazes. And again. And then if you're ever wondering, the answers are in the back of the book. I usually put the answers in the back of the book. That's it. So that is how to minus the 5. Okay. How are we doing? Oh, I think I am about done, actually. Thank you, everybody, for joining. Thank you, everybody, for joining. For those of you that are interested, I do have books in my TikTok shop. I also have books available here. But I think I am going to head out. I've been on for a little bit. I don't think I'm going to be doing that. Oh, wow. I'm at 31,000 likes. Thank you guys so much for that. Thank you guys so much for the likes. I do appreciate it. I do appreciate it. But I think I am going to head out. I think it's time. I think it is time. It's like 3 in the morning for a lot of people. 3 in the morning. You guys are crazy. Thank you so much for liking the live. Thank you guys. So I will see you all in my next live. Not tomorrow morning, but definitely tomorrow night. I do plan to come on a little bit earlier, so maybe 8 Pacific Standard Time, if I don't get too involved with what I'm trying to do. But thank you again, everybody. Thank you again. What we just did is learn a little bit about the abacus. Thank you again. So, for those of you that are interested, don't forget to follow, like, and subscribe, all the other things. And I will see you all in my next live. Have a good night, everybody. Have a good night. Good night, everybody. Go to sleep. Go to sleep. Hopefully this will encourage everybody to go to sleep. Jaijen, 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 poetic justice, poetic equation. Thank you so much. Good night, Izzy. Thank you so much for your patience, especially for yesterday. Whew, that was a tough one. Thank you, Hunter. Not a problem. I really enjoy talking about Abacus, and we just went all over the place today. Thank you. Have a good night. Have a good night, and I will see you all in my next live. Yeah? I hope to see you all in my next live. Maybe I'll go a little bit longer, depending on my energy. All right. Have a good night, everybody. Thank you so much for joining. Bye.